Simon says subscribe and click on the bell icon to receive notifications.
We've made the files the instructor uses in this tutorial available for free. Just click the link below in the video details to get these.
Hello everyone and welcome to the Excel 365 Intermediate course. In today's digital era, proficiency in Microsoft Excel has become an essential skill for professionals across various industries. Whether you're a business analyst, an accountant, an educator, or even a student, mastering Excel empowers you to efficiently manage data, analyze information, and make informed decisions. Building upon the foundational knowledge covered in our Excel for Beginners course, this intermediate level training aims to enhance your expertise and unlock the full potential of Excel 365. Throughout this course, you're going to delve deeper into Excel's robust features, functions, and tools, equipping you with the advanced techniques to tackle complex tasks and streamline your workflow. From data manipulation and analysis to advanced formatting and visualization, this course will provide you with practical, hands-on experience to elevate your Excel skills to the next level. Whether you're looking to optimize your productivity at work, gain a competitive edge in the job market, or simply expand your proficiency with Excel, this course is designed to help you achieve your goals. Hi there, my name's Deborah Ashby. I'm a Microsoft MVP and course instructor, and I'm going to be your host. So without further ado, I think we're ready to dive into the first lesson. So I'm going to head over there now, and I look forward to you joining me. It's time now to do exercise 1, the first exercise of the course. And this exercise is a little bit different from the rest of the exercises that you'll find in this course because we've only just started. We've just done the introductory lesson. So really at this stage, the only thing I need you to do is ensure that you've completed the Excel 365 for Beginners course, or you already have Excel basic skills. Remember, this is an intermediate course, and so there is an assumption of basic Excel knowledge. And the second thing to do before you dive headfirst into this course is to make sure that you've downloaded the course and exercise files and that you've stored them somewhere safe. The course files are there for you to follow along with me, and the exercise files are to complete all of the exercises throughout the balance of this course. Make sure you've done both of those two things, and we are just about ready to dive into the next section. When most of us are asked to put together a spreadsheet, we tend to dive into this task without giving too much thought to the design or the structure. And whilst the result of simply just entering in data into a spreadsheet without thinking too much about it might be sufficient for the task at hand, and your manager might be completely happy with the spreadsheet that you've produced, it can cause problems further down the line if you haven't really thought about how you're designing it. For example, if you've spent a long time working on a spreadsheet and you haven't protected it in any way, when you share that with other people, when it comes back around to you, you might find that you have lots of errors in that spreadsheet, or maybe formulas that you didn't intend to be changed have been changed. Or maybe you're getting lots of questions from your colleagues about where they should enter their data, what type of calculations they should be using, which can become very time consuming. Or maybe when you originally set up this spreadsheet, you didn't really think about the future. So in 6 months' time, when you come back to that spreadsheet and you need to make changes to it, you find that you're really having to spend a lot of time modifying different formulas in different cells, as opposed to just being able to update one figure and have everything else in the spreadsheet automatically update. So it's things like this that we really do need to think about at the design stage. So what I've done here is I've put together some golden rules of spreadsheet design that would be very helpful to think about before you get too far into the creation process. So let's take a look at them. Number 1, adopt a standard and implement it. So this relates to adopting a consistent convention when it comes to things like cell formatting, fonts, colors, and file names. It might be that you work at an organization that has branded colors, and so the colors that you're using in your spreadsheet need to be from a specific palette. Whatever colors you choose to use, make sure that they are appropriate for the type of spreadsheet that you're putting together. They add to the data and don't distract. And you use color consistently across your spreadsheet, and it doesn't end up looking like a rainbow. Also, when it comes to fonts, make sure that you're using a font that's easy to read. Arial font, Calibri font, those are always great examples of font that works well in Excel. Stay away from some of the fancier font, which again is really going to distract from your data and make it difficult for other people to read. Put things like large data sets into tables so that they look organized, and use borders and background fills to highlight certain pieces of data. Even when you're thinking about naming your spreadsheets, try and implement a consistent file naming convention. If the spreadsheet relates to an invoice, maybe think about using a prefix in the file name like INV and then maybe the date. If it's a report, maybe use a prefix like RPT, so immediately if you're looking at your files in File Explorer, you have a rough idea as to what's contained within that spreadsheet. All of these things really help you adopt a consistent standard. Number 2, try and ensure there is an appropriate level of knowledge and competence within your team. If you have top-notch Excel skills and it's your job to put together the majority of the spreadsheets, but you're sharing those spreadsheets with colleagues who have very basic Excel skills, that can cause problems. So it's a really good idea to make sure that the people within your team have not only had the sufficient training, but they have the knowledge and skills to work on your spreadsheets without having to ask many questions or maybe cause problems with that spreadsheet. Number 3, identify your audience. Ensure that the design is appropriate for your audience and it's as clean and simple as possible to understand. It's really important when you're putting together a spreadsheet to think about who's going to be looking at this spreadsheet. Is it just going to be internal? Is it just your team colleagues? Is it your manager? Or is it going to a client or up to stakeholders? Maybe it's a personal project that you're working on. Maybe you're putting together something for your after-school club, and so therefore have a little bit more leeway on how professional that spreadsheet needs to look. So think about whose eyes are going to be on this spreadsheet and design accordingly. For example, if this is a professional business spreadsheet that's going to go to clients, you're probably not going to want to use something like Comic Sans font. You also might not want to add any images that appear too cartoony or colors that are very lurid. So think about your audience prior to starting out with the design. Number 5, include a welcome sheet with instruction. It's always good to provide a welcome sheet with your Excel spreadsheet, which has instructions on how to use the spreadsheet. And this is really something that I don't tend to see a lot of people do, but it can be so helpful, particularly if you're sharing this workbook with lots of people. Simply having a worksheet at the beginning called How to Use can offer valuable instructions so people aren't confused as to how to use the worksheet and where they need to input their information. It might provide some guidance as to where that user needs to enter their data or what they need to do. And you can add things onto this sheet such as keys or legends. So if you have lots of formatting in your spreadsheet, let other people know what that formatting means. You might want to give some guidance about where this worksheet needs to be saved once they've made changes. Or you might even want to go a stage further and have a versions worksheet that people update once they've made changes. All of this type of information is so useful when you're sharing your workbooks with other people and really cuts down the amount of questions that you're being asked. Number 6, separate your data. Make sure that you have your source data, your calculations, and your analysis on separate worksheets to avoid confusion. Excel is one of the best tools out there when it comes to analyzing data. So if you have a whole bunch of sales data like I have just here, you want to ensure that you have your raw data source, your sales data, on one worksheet, but any calculations you perform based off of this data, you want to keep those separate on a different worksheet. If I'd put these on the same worksheet as the source data, things can start to get really confusing, and it really doesn't assist with readability for other people. I would also then put my analysis of that data on another worksheet entirely. So my analysis might be something like taking that source data and creating a pivot table or creating some kind of chart. So don't try and cram all of these different things, your source data, your calculations, and your analysis onto one worksheet. Separate everything out. Design for longevity. Make sure that you future-proof your spreadsheet and allow for future changes. Now, this is a really important one. As I said at the beginning, we tend to just put our data into a worksheet, and sometimes we don't really think about having to use that worksheet in 6 months or a year's time, particularly when it's been circulated around numerous people. So make sure you think about using things like Excel tables, which is going to make updating your data a lot quicker and easier. And the golden rule here, never hard code values into your formulas. For example, if we take a look at this tax column, I'm currently clicked on cell I6. I have a formula here which is just multiplying the sales value in cell H6 with the sales tax. Now, instead of typing in or hard coding the number 15% into this formula, I've used a cell reference. So if this sales tax changes in 6 months' time to 20%, it means that I'm not having to go into the formula and change 15 to 20 in everything in this tax column. I can simply change it in one cell and all of the formulas will automatically update. So don't hard code numbers into your cells and think about using things like tables. Use a consistent, clear structure. So think about color coding your worksheets and use cell styles to identify input, output, and calculation cells. It's good to get into the habit, particularly when you're working on larger workbooks that have lots and lots of different worksheets, of color coding those worksheets. So worksheets that contain related data or similar data make the tabs all one color. For example, if you take a look at my tabs in this workbook, you can see that the 3 that are in green are all kind of related to each other. So it's a really good visual indicator of which worksheets are related to other worksheets. Another thing that can be really helpful is to use something called cell styles. And we're actually going to talk more about this in the first lesson. But what cell styles do are basically let the user know which cells are input cells, i.e. which ones they can change, which ones contain calculations, which ones contain a heading, which ones contain warnings, so on and so forth. And once you have cell styles in your workbook, you can then add those into the legend on that welcome sheet so that people understand exactly what each of these formatted cells mean. Another thing that really assists with keeping your spreadsheets looking clean and clear is by removing the grid lines. You can see on all of my worksheets, I don't have the Excel grid lines showing. I have a really nice clean white background, which really allows the focus to be entirely on the data. And finally, a really important golden rule: control data input. So keep worksheets error-free using data validation and protection. If you're sharing your workbook with lots of other people, as I mentioned at the beginning, the more people who have access to your workbook, the more likely it is that somebody's going to change something that's going to cause an error. And you really don't want to be spending a lot of time putting together a really nice worksheet with lots of whizzy formulas in it, only to have someone break the formula the first time they use it. So we can help with that by controlling access to certain parts of our worksheet. For example, you could think about using things like data validation drop-down lists to control exactly what users are entering into the cells. With this drop-down list just here, nobody can free type into that cell. They are forced to select one of the options that I've set up in this drop-down list. It also might be that you want to add protection to the worksheet or even the entire workbook so that people can't edit specific cells. So if you have a cell that contains a formula like this one just here, if I don't want anybody changing what this formula says, I can choose to protect this cell, but keep everything else unprotected so they can do things like select manager names. They simply can't edit the formula. Notice if I try and edit anything, I'm getting a message pop up because I've applied protection. So there's lots of things we can do in Excel to control the data that's going into our spreadsheet to keep them as error-free as possible. So those are my golden rules when it comes to designing spreadsheets. Have a little think about your work and how you might adopt some of these approaches. One of the tools available in Excel that you can use to improve readability and make your spreadsheets more user-friendly are cell styles. And I always find that cell styles seem to be often overlooked by people. Essentially what cell styles are preset formatting. And you can use this formatting as a visual way to indicate things like which cells contain formulas and which cells can be edited, which cells contain warning messages, notes, so on and so forth. And all of the formatting can be customized so you can choose your own colors. So let's take a look at how this works. So my data set here is just an invoice spreadsheet for some clients. So I've got some invoice numbers, some invoice dates. We can see the amount of each invoice. And then the final two columns, VAT and total, these columns actually contain a formula. So you can see that this value is calculated by multiplying the amount by the VAT percentage in cell K3. And then the total is a simple sum calculation of the amount plus the VAT. So maybe in this spreadsheet, I want to let people know in a visual way that the cells in these two columns contain formulas and shouldn't really be edited. Now, one point to note here is that cell styles don't do anything like lock cells or prevent people from editing. They're just a visual indicator. And I'm going to show you in a moment why it's always best to add some kind of legend so that people know exactly what all the different colors mean. But when it comes to applying cell styles, this is so simple. Check this out. So we're going to press Ctrl-Shift down arrow to select both of these columns. And on the Home tab in the Styles group, we're going to click the Cell Styles drop-down. And you can see we have lots of different cell styles in here. As I said, these don't have any functionality, so to speak. They're just simply formatting. And the colors you see in here, particularly for that group themed cell styles at the bottom, those are being picked up from whatever theme you have set. So I'm using the standard office theme, so I'm getting the standard office colors. Now, I want to denote these as cells that contain calculations or formulas. So notice in the data and model group, we have a cell style called calculation. So I could go in and I could just apply this style, no problem. However, if you look at this and think, I actually really don't like the formatting, I don't like that orange font, and I don't like the shading, you can, of course, modify any of these cell styles. Now, I don't recommend that you right-click and modify the cell styles that are already here. What I would say to you is always make a duplicate of the cell style and then modify it to create your own custom style. So let's go for duplicate. We can give our style a name. I'm going to call it formulas, so it's a little bit different. And then I'm going to click on format, and we can customize how we want this to look. So maybe I want the font to be, let's go for just a darker blue. Let's go for a border. Now I'm going to let's put a dark blue border around the outside as well. And then finally, I'm going to add some background shading. Let's just add a light blue background. Click on OK and OK again. And now when we go to cell styles, you can see we have a new group at the top called custom, and that contains our new custom cell style. So I can apply this and check it out. Now notice what it's done here. It's removed the accounting number format from the style. So what I would do is go back in, right click, I can modify my cell style, click on format, go to the number tab and make sure that I also set that number formatting for this particular style. So many different ways that you can modify these. What I'd then probably do is go in and denote these cells as cells that people can change, input cells, because people are going to be adding new invoices all the time. So let's select all of these, go to cell styles, and there we have an input cell style. Now, once again, I could keep this with that formatting, or I could change it to something else. So let's duplicate this one. I'm going to call this inputs with an S on the end. And let's change this so that we have let's go for a bright red border around the outside. And I think I'm going to make that slightly wider actually. And I'm just going to make the font just black. And the final thing that I'm going to do here is I'm going to jump across to the Fill tab and we're going to say no color. So let's click on OK and OK again. And now we can apply the cell style. So notice it's now been added to the custom group at the top. There it is, inputs. we can click to select. Now notice one important thing. Because I didn't define any number formatting within my cell style when I modified it, notice that the invoice date column is now just showing as numbers, and the amount column has also lost its formatting. So it's entirely up to you if you want to include formatting in your cell style, but if I'd included, let's say, currency formatting, it means that it's going to format any numbers, so that would include the invoice date column. So this column would also end up formatted as currency or accounting format. So what I prefer to do is just get the bare bones there, and then we can come back in and we can simply apply the relevant formatting. So I'm going to select the invoice date column, and let's make sure that's set to short date, and the amount column, I'm going to change that to accounting formatting with 2 decimal places. Now the cool thing about cell styles is that if we have our data in a table, when we go to the bottom and add a new invoice, let's just add IMV 0025. And let's just add another date in here, and we'll say Computech, and we'll just add a value. Notice that the table auto expands to accommodate that new record, and the cell style carries through. We don't have to do anything extra to apply that cell style. Now, a final couple of things I would probably do here. I would also make the VAT cell, this cell just here, an input cell, because the VAT might change at some point. So I want to let people know that they can actually modify this cell. So once again, we're going to go to cell styles. Let's choose inputs. So I would simply add percentage formatting just to put that back. Now remember, when it comes to cell styles, we have lots of other styles in here as well. For example, things like titles and headings. So what I could do here with the spreadsheet title is I could select this cell, which includes all of this text, go to cell styles and maybe choose title style, just to give it a bit of structure. And of course, something that's really important is adding a legend or a key so that everybody knows what these cell styles mean. Now, normally I would add the legend or the key onto a summary sheet, and we are going to talk about that in the following lessons. But just to give you an idea, what I would do somewhere is I would select a cell, I would add the formulas cell style, select the cell underneath, add the inputs, and then I would just write some text so everybody knows what these colors mean. So there we go, calculation cell do not edit, input cell can be edited. So that is how you can use cell styles to improve the readability of your spreadsheets. When working in Excel, and particularly if you're going to be sharing your spreadsheets with colleagues or other people, it's really important that you control the data that goes into the spreadsheet. And we're going to explore a couple of methods that we can use to ensure that our spreadsheets remain as error-free as possible. So what do I mean by that? Well, if you take a look at this spreadsheet just here, we have a list of employees. And in here we can see their department and their salary. Now, if I share this spreadsheet with, let's say, 10 other people, anybody can go into this spreadsheet and start making changes to these cells. Now, that might be fine. This might be a list that you want people to keep updated, but there might be certain cells or certain parts of this worksheet that you just don't want them to touch. For example, if you take a look in column I, you can see we have a couple of NA errors in here. Now, don't worry about those too much at the moment. If we click on one of these cells, you can see that it contains an index match formula. And again, if you're not sure what an index match formula is, we're going to cover that in a couple of sections' time. All you really need to note now is that these two cells both contain formulas. Now, what I don't want to happen here is that when I send this spreadsheet to somebody else, they come into one of these cells and change this formula. Because it might be that the person who's changing it doesn't have particularly good Excel skills and they break the formula, or it might be that they accidentally touch their keyboard, drop something on their keyboard, add something into the formula, and then again it's broken. So we want to make sure that we put in as many controls as possible to ensure that things like this don't happen. Now, what we're aiming for here is in cell I3, I want to be able to type in an employee name and have it return the department and the salary. And that is basically what these index match formulas are going to do. They basically look at the name that we have in cell I3. They then look in the table, they find that name, let's say Lee Anderson, for example, and they'll return the department and the salary for that employee. So let's type in Lee Anderson just here. And when I hit enter, we should find that it returns the department that he's in and the salary because of these formulas. Now I can see that the salary doesn't have any formatting. So let's fix that. Let's apply some accounting formatting with 2 decimal places. So that's working fine. But what if I come in here and I type in, let's go for Laurie May and hit enter. I'm getting NA errors. Now, Laurie May does exist in the table, so why are these formulas not returning the department and the salary? Well, if I take a look at my employee name, I can see here is Laurie May, but notice that I've spelt her name wrong. So instead of an I on the end, I've used a Y. So if you have a spelling mistake in your lookup, it's not going to return the correct result. And this can reflect really badly on you, because if you go back to your manager and say, well, Laurie May doesn't exist in the table according to my formulas, when they're actually there, then that isn't really a good look. So the method that I would use to ensure that people are inputting the correct names every single time is to use a data validation drop-down list. So what we're going to do here is let's just add employee at the top. Make this a bit wider, and I'm just going to use my format painter to copy that formatting because we're going to add a little data validation drop down. So let's go to the data tab, over to data tools. We're going to choose data validation, and on the settings tab, we're going to say that we want to create a list. Now the source for our list, well, we want to list all of the employee names. So I'm going to go to the first name in the employee name column, Control-Shift down arrow to select the entire range and click on OK. So now I have this little drop down and I can select the names and it's correct every single time. So this really safeguards against spelling mistakes and people just entering in the wrong thing into the cell. So consider utilizing data validation lists. Now, the second thing that I'd like to show you in this lesson is how to protect individual cells. Because now we have our nice data validation drop down, our formulas underneath are working perfectly. Now, what about if I want to send this spreadsheet to other people? I want them to be able to edit the employee details down here and add new employees onto the bottom. I also want them to be able to make selections from this drop down, but I don't want them to be able to click in either of these 2 cells and start changing the formula. So what I can do here is I can protect these 2 cells that contain those formulas and leave everything else unprotected. Now, protection, I always think works a little bit backwards. And the principle you need to get your head around is that every cell in Excel by default is locked. Now, you might be thinking, well, if every cell is locked, how can I just type into any cell? And if you don't believe me, let's right click on a cell. Let's go to Format Cells and the Protection tab. Notice the locked checkbox is selected. And you'll find that no matter what cell you click in your spreadsheet. Now, the reason why we can still type into locked cells is that this locking doesn't take effect until we protect the worksheet. So until then, everything is still unlocked. So if we want to make certain cells editable and other ones locked, what I would do here is I would select all of the cells that I want people to be able to change. So I'm going to say Control-Shift down arrow. I also want them to be able to use that drop down. Then I'm going to right click, go to Format Cells, and we're going to unlock those cells. Let's click on OK. So now when I go up to the Review tab, I'm going to say Protect Sheet. I'm not going to use a password. Let's click on OK. And now what we'll find is that these cells are still editable. So if I go down here, I could change this to sales, not a problem. But if I try and make any changes to these 2 cells where we have the formulas, I'm going to get an error message. It says the cell or chart you're trying to change is on a protected sheet. So these 2 cells are protected or locked, and everything else where I need to make changes, all of those cells are editable. Working quickly and efficiently in Excel is the name of the game, and that is extended to being able to navigate quickly around our workbook. And that's particularly important if you have a workbook that has lots and lots of different worksheets. For example, this workbook that I have here has quite a few different worksheets, and I want to be able to jump around between these worksheets in the most efficient way possible. So in this lesson, I'm going to show you a few different methods when it comes to navigating and some cool little things that you can add into your spreadsheet to make it really easy for yourself and anybody that you share this workbook with to get to the worksheet that they need quickly. Now, the simplest way of jumping to another worksheet is to come all the way down to where we have our tabs. Can you see these two arrows in the left-hand corner? If you hover your mouse over any of these arrows and right-click, notice that we get this little menu pop up, which lists out all of the worksheets in our workbook. So if I want to quickly jump to the analysis worksheet, I can select analysis, click on OK, and it's going to take me there. So that's a really useful little quick tip. But how else can we navigate between workbooks? Well, we could add a hyperlink to certain pages. So let's go to the sales data worksheet. Maybe I want people to be able to very quickly jump across to the analysis worksheet from this sales data worksheet. So what I could do is I could add a link. Now I'm going to add another row into the top here because I'm going to put my link just here. So I'm going to say go to the analysis worksheet, and I'm going to make this a hyperlink. So with this text selected, I can either right click and go down to link. Alternatively, I can press the keyboard shortcut Control K, which is going to jump me to the insert hyperlink dialog box. Now, there's lots of things that we can link to from within here. We can link to external websites. We can link to email addresses. We can link to other workbooks, or we can link to other worksheets within the same workbook. Now, to do that, we need to go to Place in this document. And this is where you'll then see all of the other worksheets listed out. So I want this to go to the analysis worksheet, so let's make sure we select it. And notice just above, we can also type in the exact cell reference that we want to jump to on that analysis workbook. So by default, it's going to be cell A1, which a lot of the time will be perfect. Just so you can see, let's change this to A10. We can also add a screen tip in here so that when people hover their mouse over this hyperlink, it basically tells them what they need to do. So we can put instructional text in here. So click here to see the sales analysis report. Let's click on OK. So you can see that that's now a hyperlink. And again, if I hover my mouse over it, I'm getting that little screen tip. Click here to see the sales analysis report. And if I click on this, it's going to jump us across to the sales analysis worksheet. And notice where my cursor is. It's in cell A10. So that is a really nice, simple way to navigate. Now, what else could we do to make these links more interesting? Well, we could hyperlink from a picture or an icon or a shape. We could create our own button. So instead of having a text link, maybe I want to make myself a little interesting button. So let's go to Insert. We're going to go to Shapes, and I'm going to draw a rounded rectangle. And here I'm going to say, see the analysis report. So then we can format. So I'm going to change this to Aptos font. I'm going to put it in the center. Let's make it a little bit smaller. And in fact, I'm going to make that a little bit wider. And then we can change the button color to match our color scheme. So let's go for a green background fill. And I think I'm going to go for a dark green shape outline. So now I have a useful little button instead, and I can put this wherever I need to put it. So maybe I want to put it at the bottom here, and then I can run through the same process. So Control K, I can select the analysis worksheet. I can select the cell I want to link to and add a screen tip if I want to. Click on OK, and now this becomes a helpful little button, which is going to jump us to the same worksheet. Now, you're not limited to linking from text and shapes. You can also use pictures and icons. So let's take a look at one more example. I'm going to insert an icon, and I'm going to search for an icon of a house or a home. So let's just choose this one just here and click on Insert. Now, with these icons, you can change the color of them from the graphics format tab. So again, I could make this the green color. I want this to stand out a little bit. So let's make it purple. I'm going to make it a bit smaller. And then what I could do is I could place this somewhere on the worksheet and maybe link this to the first worksheet, the home worksheet, for example. And this is something that I quite like to do because a lot of the time the first worksheet in the workbook will contain a lot of useful information. So it's good to have a way that people can quickly jump back to home if they need to. Now I'm just going to put mine, let's just put it up here. Now I could copy and paste this onto every single worksheet so that we have some consistency and can easily jump back to the home page whenever we need to. But with regards to linking, this works in exactly the same way. We can press Control K, and this time I'm going to select How to Use, click on OK, and now if we click on this, it's going to jump us back to that first page. So those are a few different methods that you could employ to help your users navigate around a large workbook. In this very quick lesson, we're just going to talk about summary sheets and why you should be adding them into your Excel workbooks. So what exactly is a summary sheet? Well, a summary sheet in general is a worksheet that appears at the beginning of a workbook. So you can see here that I have a workbook open. This workbook contains many different tabs with different types of data on each tab. And what I've done here is I've added a summary sheet to the beginning of the workbook. So if you take a look at my tabs at the bottom, you can see I've added this one here that says How to Use. Now the idea of a summary sheet is that anybody looking at this workbook or trying to interpret this workbook, it just gives them a little bit more information about exactly how to use the workbook. So I've labeled the tab How to Use, and on it I've just listed out some important information. So you can see at the top here we have a little table of data with some instructions. So it goes through some of the tabs and lets them know exactly what they need to do on each tab. For example, with the Calculations tab, it says perform any calculations on the Calculations tab. So if we go across to Calculations, they know that they need to perform any calculations for this workbook on this specific tab. With the Dashboard tab, it says refresh the dashboard weekly to update data. Filter data using the slicers only. So it just lets people know exactly what they should be doing on each tab. Then we move down to cell styles. Now we looked at cell styles in a previous lesson. These allow us to color code different cells, again to guide people so that they know what type of information should be going into those cells. And I mentioned in that lesson that it is important to have a key or a legend letting people know what those cell styles mean. And this is in general a good place to put it. So we put it on the summary sheet so people know that any cell that is colored in orange is an input cell, anything that's gray with orange font is calculation, so on and so forth. And we've also got a bit more information at the bottom here with regards to saving. So it says if you amend this spreadsheet, save it as a new version in this folder. So again, it prevents people from naming files incorrectly, and it ensures that they know exactly where they need to be storing any new versions that they create of this workbook. And then finally at the bottom we have versions. So update the versions tab whenever a change is made, add your initials, the date, and the details of the change. And that's pretty much all there is to a summary worksheet. You can put whatever you like on the summary worksheet. Any information that you think is going to be helpful to people will prevent errors from going into the cells and will just make your workbook in general easier to read and interpret. In this lesson, I'm going to show you how you can make your data input a lot quicker by using forms in Excel. So what exactly do I mean by this? Well, if you take a look at the worksheet, we just have a small data set just here that lists out some invoice data. So in column B, we have the invoice date. We then have an invoice number, the client that the invoice belongs to, the amount on the invoice, and the status, so whether it's late or if it's been paid. Now, it might be that it's my job each week to update this invoice list. So as we send out new invoices, I want to add more invoices to the bottom just here. Now, I could, of course, just go to the bottom cell and start to type in the record, or I could use a form. And sometimes using a form makes this entire process a lot quicker because it allows you to move between records efficiently. It allows you to add new records really quickly, and you can also delete records super fast as well. Now, if you're hunting around on any of these ribbons up here looking for the Forms button, then unfortunately you're not going to find it, because forms isn't a command that's on a ribbon by default. So we need to add it. And the easiest way to do this is to add it to the quick access toolbar. So if we go to our QAT, click the drop down just here to open up the Customize menu, and we're going to go straight down to More Commands. This is going to jump us across to Excel Options and to the Quick Access Toolbar page. Now from here, we can choose how we want to sort our commands. So currently, I'm only showing popular commands in the list below. Now, in general, I tend to switch this to all commands so that I know that I'm seeing everything that's available to me. And these commands are organized alphabetically, which makes it a little bit easier to find. So we're looking for the forms command. So I'm going to scroll down to where we have all of our Fs, and there it is, just there, form. Let's select it, and we're going to click Add to add it to our QAT. When we click on OK, we should see it now sitting up here. Now, before we click on this form button, I would always advise you to put your data into an Excel table. So let's press Control T. Yes, my table has headers. Let's click on OK, and you can see I'm getting the default formatting. Now, you can change that from the table styles dropdown if you want to. This isn't a necessary step. You can just leave it as it is. But in general, I usually change the default. I'm going to change it to this one just here, dark green, table style, medium 18. And of course, then if you go to the table design ribbon in table style options, you have some choices with regards to if you want banded rows turned off or on. Now I have mine turned on currently. If I deselect this checkbox, it's going to turn those banded rows off. Now, why do we use banded rows? Well, a lot of the time it makes it a lot easier to read across the record. So I'm going to leave mine on. So we've got our data in a table. We have our forms button ready to go. Let's use it. So let's click on it and check out what happens. We get this useful little form which has picked up all of the column headings in our data set, and we can see them listed out here. We also then have a group of commands that we can use. So if I wanted to enter a new invoice to the bottom here, I can simply click the new button and I can type in the invoice date. So let's go for 1/15/2024. Invoice number is IMV-1028. Tab. Client is client 15. Tab, let's say the amount is $200, and the status will say that that is late. And you can see as soon as we click on the new button, it adds that new record into the table. It also leaves the form dialog box open, so you can then just quickly jump to the next one and add another new record if you want to. And that's really all there is to using forms to input data. As I said, this can make your data entry a lot quicker, and it's a great efficiency tip to know.
For the next section, you'll want to download the course exercise files. Click the link below in the video description to get these. You can also scroll through the details to find timestamps for each section in this course. If you're enjoying this training, please leave us a comment.
It's time now to complete exercise 2. And in this exercise, we're going to practice some of the skills that we've learnt in this section of the course. Now, notice here that I have a table of data that lists out some product IDs, the product name, the price of each product. We have a blank sales tax column, and then we have the status of the product, so whether it's in stock or out of stock. Also notice in cell H1, we have a sales tax amount of 20%. Now, the first thing I'd like you to do is format this data set as an Excel table. I'd then like you to calculate the sales tax for each product in column E. I'd then like you to indicate that columns B, C, D, and F are input cells. And then I'd like you to add the Forms button to the Quick Access toolbar and use that Forms button to add another record to the bottom of the dataset. And you can see the details of the record that I'd like you to add. And what you should find is that if you've done all of this correctly, the sales tax field will automatically update. That's it for now. I will see you in the next section. In this section of the course, we're going to shift our focus to taking a look at logical functions. Now, there are so many logical functions in Excel. If we go to the Formulas tab and go to the Logical drop-down in the Functions library, you can see we have all of these in here. And logical functions basically allow us to perform a test on a piece of data, and then depending on if the output of that test is true or false, we get our result. Now we're going to explore logical functions in detail throughout the balance of this section, but I just wanted to spend this very first lesson just doing a basic recap of exactly what logical functions are, just so that we're all on the same page moving forward. So on this first worksheet here called Basic Logical, we have a small table of data that just lists out some expenses. So maybe these are a list of employees and we have the total of the expenses that they've incurred. And then we have an empty column just here, column C, where we need to work out if these employees require approval for these expenses. And if we take a look over in column F, you can see we've got a little bit of information. So it says expenses over the following amount must be approved, and the threshold is $1,000. So anything over $1,000 requires approval from a manager. So what we essentially need to do here is we need to get Excel to test each of these cells in column B to check to see if the value is greater than 1,000. If it is, then approval is required. If it isn't, then approval is not required. So the way that we can do this is to use the if formula. Now, when you're working with if or any logical function, it's important to understand logical operators. And you can see a little table. This is just a picture that I've copied and pasted in from the Microsoft website. This lists out the conditions and the relevant operators. So what exactly do all of these mean? Well, let's just type in number 5 and number 6 into a couple of cells. I could run a logical test here, and for this I don't even need to put if in front of it. I could type in equals and I could test if the value in this cell is equal to the value in this cell. So is 5 equal to 6? When we hit enter, we get a result of false. And that's another important point to note. The result of a logical test is always either going to be true or false. So let's double click to edit the cell, and this time we'll change the operator to the next one in the list. So this time we're testing if cell G11 is greater than cell G12. When we hit enter, we get false because 5 is not greater than 6. Let's do one more because I think you get the idea. We'll go to the next one in the list. This time we're going to test if G11 is less than G12. And you've probably guessed the answer here. It is true. So this little table will help you out when it comes to deciding which operator you need to use. Make sure you commit those to memory. Now, in those examples just there, we weren't using if statements. We were simply typing in equals and then selecting the cell references. So why do we use if? Well, let's type another couple of numbers into some cells. I'm going to type in 10 and 20. So if I was performing a logical test on these, I could say, is 10 greater than 20? Hit enter, my answer is going to be false. As I mentioned, the answer is always going to be true or false. Now, what if we want to assign something a little bit more meaningful to these true and false labels? Maybe instead of true, I want it to say yes, and maybe instead of false, I want it to say no. Well, that is where if statements come in, because if statements help us give meaning to logical tests that we perform. So what I could say here is if I click at the beginning, I could type in if, let's open a bracket, my logical test. Well, that is what we have here. We're testing if G11 is greater than G12. So if we move to the end, comma, we can then specify what we want it to say in the cell if the answer is true and what we want it to say if it's false. And if we want to output text, then that needs to go into quotes. So if it's true, I want it to say yes. If it's false, I want it to say no. Let's close the bracket, hit enter, and you can now see we have our answer of no because 10 is not greater than 20. So that's the basic premise of how if statements work. Let's now take that and apply it to our expenses table up here. So if we click in this cell, we're going to type in equals if, open a bracket, logical test. What is our logical test in this case? Well, we want to test if cell B5 is greater than G5. So effectively, is 800 greater than 1,000? Now notice here it says expenses over the following amount must be approved. So it doesn't say expenses over and including the following amount. If that was the case and we wanted to include anything with 1,000 exactly, we would do greater than or equal to. But we just want over, so we're going to leave it on greater than. Now, in a moment, we're going to copy this formula down to the rest of the cells. Now, when we pull this formula down, the cell references are going to move and update accordingly. Now, we don't actually want G5 to move because we always want to reference this cell. So we need to make sure that we press the F4 key to lock that cell reference in place. And then we can say, if the expense is greater than 1,000, we want to output yes. If it's not, we want to output no. Close the bracket. I'm going to press Control Enter to stay in the same cell and then double click to copy that down. And you can see here with this expense that is exactly 1,000, approval isn't required because it's not greater than 1,000. So that is how basic logical formulas work and how a very simple if statement works. In the last lesson, we did a quick recap of how basic logical functions work. And in this lesson, we're going to move that on a little bit and see how we can incorporate two more logical functions, and or. And we've got a few different examples to work through on this page. So let's start out really basic at the top and we'll build from there. So in this first table at the top here, example 1, we have a list of student names and then we have the score that they achieved in a test. And what I want to output into these cells are whether they've passed or not. And you can see over on the right hand side, we have the pass mark that they need to achieve in order to get a result of pass. So anything under 85 is going to be a fail, which I think is pretty harsh. Now, this is just a basic if statement like we did in the last lesson. So let's type in equals if. What is our logical test? Well, if the score, and this time we're going to say is greater than or equal to 85, and we're going to press F4 to lock that cell reference. If that is true, then they have passed. If it's not, then they have failed. Let's close the bracket, Control Enter to stay in the same cell, and then we can double click to copy down. So we can see that anything that is 85 or above has a result of pass. Anything that's under 85 has a result of fail. Nice and basic, nice and straightforward. Let's move on to a more complex example. Now, this time we have a list of products. We have the weight of each of those products and we have the price. And we need to calculate the shipping fee. And if you take a look over on the right, you can see that we have weight, 30, shipping fee, 20%. So what we're saying here is that if any of these products has a weight of 30 kilograms or more, there's going to be a 20% shipping fee charged. And that's going to be 20% of the overall price of the product. So this is an example of how to use a calculation within an if statement. So let's type equals. We're going to say if. What is our logical test? Well, we want to test if the weight is greater than or equal to 30 kilos. F4 to lock that cell. Now, if that is true, if it is greater than or equal to 30 kilos, then we want to work out what 20% of the price is. So this is where we need to perform a calculation. So if that's true, we're going to say calculate 30% of 500. Now to do that, we simply need to select the cell C14 and we're going to multiply it by the shipping fee. And again, we need to press F4 to lock that shipping fee in place because we don't want it to move when we copy the formula down. Now, if it's false, there is no shipping fee. So I'm just going to have a blank cell and we represent that with 2 quote marks. Let's close off our if statement. Let's press Control Enter. And we should find that when we copy this down, wherever we have a product that is 30 kilograms or higher, we now have a shipping fee total in column D. The other cells will remain blank. So that is how you can use formulas within your if statements. Now let's move down the page a little bit and take a look at and or. Now and or allow you to perform multiple logical tests. In all of the examples that we've seen so far, we've been performing one logical test and specifying what we want the result to look like. This time we're going to test multiple conditions. So again, we have a list of student names, and this time they've sat 2 separate tests. And we've got the score that they achieved for test 1 and the score that they achieved for test 2. And you can see over on the right-hand side, the pass marks that they need to achieve for each test in order to receive an overall result of pass. So we're going to say that anything Greater than or equal to 75 in test 1 is a pass, and anything greater than or equal to 65 in test 2 is a pass. So we're going to use the AND function. So let's type in equals. We're going to say AND. Notice here the arguments logical 1, logical 2, logical 3, logical 4. We can perform many logical tests. So what is our first logical test? Well, if score 1 is greater than or equal to 75, F4 to lock that cell, comma. We then go straight into logical 2. So our second logical test is AND if this score is greater than or equal to 65, F4 to lock. So what we're saying here is that both of these need to be above the pass mark in order to receive an overall result of pass. Now, if I just leave it like that and hit enter, we're going to get a result of true or false. And it's true because this score is greater than 75 and this score is greater than 65. So both of these are true, giving us an overall result of true. Now, I don't want it to say true, so this is where we can wrap it in an if to make it more meaningful. So we've got our logical test, that's everything in this AND formula. We can jump straight to the end, and if it's true, we can say pass if both of these are true. And if even one of them is false, we need a fail in there. Let's hit enter, double click to copy down, and you can see the results just there. So for example, this one that says fail, it's a fail because test 1 is below the pass mark, even though test 2 is above. Because with the AND formula, we need both of these to be true in order to get a pass. So you can use AND to perform multiple logical tests. Now, OR works in a very similar way, except this time, instead of saying both of them need to be true, only one of them needs to be true in order to achieve a pass. So again, we have students, we have their scores in 2 tests, and they only need to get above the pass mark in one of these tests in order to get a result of pass. So let's do this in the same way. We're going to say OR this time. It's exactly the same arguments. So we're going to say if this score is greater than or equal to the pass mark, F4 to lock, or if this score is greater than or equal to the pass mark, F4 to lock. Close the bracket, hit enter. We're going to get a result of true or false. Remember, we just need to wrap this in an if in order to make this more meaningful. So if one of those is true, they're going to get a pass. If neither are true, they're going to get a fail. Close the bracket, hit enter, and then we can double click to copy down. So you can see that these are all passes except this last one because both scores are below the minimum pass mark. At this point in this section, we should be reasonably familiar with what an if statement does. So in this lesson, we're going to move things along a little bit and we're going to take a look at nested if statements. Now, nested if statements are pretty much what you might imagine them to be. They are if statements inside other if statements. So why might you want to use these and how do we put them together? Now, in this lesson, we're just using an employee database. So in column A, we have some employee names. We have the building they're located in, the department, their hire date, the number of years they've been working at the company, their salary, and then they have a job rating. And this job rating column is pivotal to this lesson. Now, this job rating might be an overall score that they've achieved in their last review, with 1 being the lowest job rating and 5 being the highest. And these job ratings might have been based on various different factors, maybe scores from other disciplines. But it ends up that every employee is given a job rating. Now, for our best performing employees, so those employees that have a high job rating, those lucky people are going to be getting bonuses. And you can see over on the right hand side here, we've got the bonuses that we're going to assign to each of the job ratings. So effectively over here, we can use if statements to look at the job rating for each employee and then match it over here in the table and return the bonus. Now, I will say before we even start doing this, you could do this using lookups as well, but we're going to use nested if statements just to practice those instead. So let's click in the first cell. We're going to say equals, and we're going to type in if. So what is our logical test here? Well, we're testing if the job rating is equal to, and we'll say 5 first of all. If that's true, they're going to get a bonus of 3,000, comma. Now, at this stage, we don't add a false argument in at the moment. We go straight into our next if to perform our next logical test. And this is why they're called nested if statements. So our next logical test is if the job rating is equal to 4, if that's true, they're going to get a bonus of 1,500, comma, next if. If the job rating is equal to 3, they're going to get a bonus of 900, and we're going to carry on going. If the job rating is equal to 2, then they're going to get a bonus of 100. And then when we get to the last one, we could specify this in the same way, or alternatively, we could just add our false argument. Because the false argument in this case will basically say, if the job rating doesn't match anything else that we've specified, then they're not going to get a bonus. So our false argument could be a blank, or it just simply could be a 0. So now we can close off our bracket, but look at how many brackets we've opened. Remember, in Excel, you always need to close off as many brackets as you open. So I'm going to add a few more brackets in, and you can see as I'm doing that, it's moving back. As soon as that little screen tip disappears, then you know that you've entered in enough brackets. It's also worth noting that if you don't enter in enough, Excel will prompt you and will fix it automatically for you. Now let's see what we get here. Let's press enter. I'm going to double click to copy this down, and well, that doesn't look too great, does it? So what have I done wrong? Let's double click. Well, I haven't made any of these cell references absolute. So as I'm dragging this down, it's moving these cell references down. So I want to make sure that I go through, and anything that's being referenced in the table in column J and K, I want to make sure that I press F4 to lock all of those references, because we don't want those to move. So I'm just quickly going to go through and do that like so. Now let's press enter, and when we double click to copy down, we should find that that looks a lot better. Now notice that we have this little green triangle in the corner. Wherever you see a green triangle, that's always a warning. Let's click to see what it says. So it's simply telling me that this is an unprotected formula, meaning I haven't locked these cells so anybody can come in and change this formula. Now I'm not too worried about that, so I'm going to select the entire column, Control-Shift down arrow. Let's click that warning triangle and just say ignore error. Control up arrow to jump to the top. So let's do a quick spot check and make sure that these totals are correct. So up here, Lisa Page, she has a job rating of 1, which means she's going to get no bonus, and that is correct. The next employee, Hector Taylor, he has a job rating of 4, which means he's going to get a bonus of 1,500. The next employee, Jonathan Dawson, he's been very good. He's got a job rating of 5, which means he's going to get a bonus of 3,000. So that is a nested if statement. And if you take a look in the formula bar, you'll see that that is pretty long. There are definitely shorter ways that we can do this, including another logical function called IFS. And in this example, we could also have used an XLOOKUP or a VLOOKUP, which would have been a much shorter formula. But this should hopefully give you an idea as to exactly what nested if statements are, so that you know how to use them if you need to. In the previous lesson, we saw how we could use nested if statements in order to calculate the bonus for each employee based on their job rating. And if you recall, I mentioned that the nested if statement formula was pretty long. So in this lesson, we're going to take a look at an alternative that is slightly shorter, and that is the IFS function. Now, the IFS function was released in 2019, so it is a newer function. Nested if statements have been around much longer, but this is a bit of a quicker notation when it comes to creating effectively nested if statements. So I wanted to make sure that you could get a direct comparison. So we're going to use the same data. We need to complete the bonus column, and we're going to determine which employee gets a bonus and how much by their job rating. So let's use the IFS function this time. So we're going to type it in. Our first argument is logical test 1. So once again, we're going to say if the job rating is equal to 5, and we're going to press F4 to lock, comma, if that's true, they're going to get a bonus of 3,000, F4 to lock, comma. Now in nested if statements, this is where we would then go in with our next if. But with the IFS function, you don't actually need to do that. You can just move on to your next logical test. So we can say, okay, if this is equal to this, F4 to lock. If that's true, they're going to get 1500. Now we're into logical 3. If this is equal to this, they're going to get a bonus of 900. And if this is equal to this, F4 to lock, they're going to get a bonus of 100, F4 to lock. And one difference with the if-else formula over nested if statements is that there is no false argument. So I could just close off the formula here, or I could specify. So if we say if this is equal to this, then they're going to get nothing. Let's close, hit enter, and then we can double clickety-click to copy down, and we should find that we get the same results. Now, once again, I can see that we have this green triangle, so Control-Shift down arrow to select the entire column, and we're going to say it's fine that the formula is unprotected. We're going to ignore the error, Control up arrow to jump to the top. So whilst this is very slightly shorter because we're not having to add in if each time, it is still quite a lengthy formula. But just know that there is an alternative to nested if statements, and I know that a lot of people do find this a little bit easier to understand. Give both methods a good practice, and I'm sure you'll find which one is your favourite. It's time now to take a look at conditional ifs. And when I say conditional ifs, I mean specifically 3 functions: COUNTIFS, SUMIFS, and average ifs. Now, you'll notice in the title here that where we have COUNTIFS, SUMIFS, and average ifs, I've put the S in brackets. Now, the reason why I've done that is because there are singular versions of these formulas as well. So COUNTIF, SUMIF, and average if without the S. Now, I've chosen not to show you the singular version in this course. What's the reason for that? Well, you don't actually need them now that we have the plural version with the S on the end, because COUNTIFS, SUMIFS, and average ifs can do exactly the same as COUNTIF, SUMIF, and average if, and they can also do more. So let's take a look at how they work. So we're going to start out with SUMIFS. Now, notice in this table here, we have a list of sales agents that work on the sales team. We have the company that they're assigned to, we have their job title, and we have the total amount of sales that they've generated. And what I want to do over here is I want to sum the sales based on different pieces of criteria. So for the first calculation here, you can see I've got Microworld highlighted in green. So basically, I want to perform a calculation that says sum the total sales when the company is equal to Microworld. So we basically have a logical test with some criteria. So what we're going to do is we're going to type in equals SUMIFS. Now, this formula has 3 arguments: sum range, criteria range 1, and criteria 1. So the first thing you need to specify is what you want to sum. So in this first example, we're summing the total sales for Microworld. So our sum range is going to be the total sales range, comma, criteria range 1. Now, the way I think about this is I like to think about what my criteria is first, and then my criteria range is just where I'm going to find that piece of criteria. So my criteria is Microworld. Where am I going to find that? Well, I'm going to find it in the company range. So that is my criteria range, comma. What's my criteria? My criteria is Microworld, F6. Close the bracket, hit enter, and I get my result. So this is the total amount of sales where the company is equal to Microworld. Now, in the next example, we're taking this up a level because we have 2 pieces of criteria. This time, I want to sum all of the sales for the sales reps at Microworld only. So let's type in equals SUMIFS. Our sum range is the total sales. Criteria range 1. Well, our first piece of criteria is Microworld again. So our criteria range is where we're going to find that, which is the company range. Our criteria is Microworld. But now if I press comma, it moves on to criteria range 2. So we can carry on going. So my next piece of criteria is that they must be sales reps. Where are we going to find this? Well, we're going to find it in the job title column. That is our criteria range, comma, and our criteria is sales rep. Close the bracket, hit enter, and we get our result. And the final example here, we have 3 pieces of criteria. So let's jump straight into our SUMIFS again. Our sum range, is the total sales. Criteria range 1 is the company. Our criteria is Microworld. Criteria range 2 is the job title. The criteria is sales rep. And now our third piece of criteria is we only want to sum sales that are greater than 7,000. So what's our criteria range going to be here? Well, it's going to be the total sales column, and our criteria is going to be this cell, or you could type in greater than 7,000. So I'm going to select the cell. Let's close the bracket, hit enter, and we get our result. And if you wanted to just do a quick visual check of this to make sure that all your numbers are correct, let's go through and let's highlight those sales. So wherever we have Microworld sales rep, so that cell just there, and there are no other records that match that piece of criteria. So the total sales should be 7139, and I can see that yes, it is. Now, COUNTIFS works in a very similar way, except instead of summing, we're counting. So let's do equals COUNTIFS. So in this first example, I want to count the total number of employees at Computech. So my criteria range is the company, comma, my criteria is Computech. Close the bracket, hit enter, and I can see that there are 6 sales agents at Computech. Let's do this example. So the next one, this time we're trying to calculate the total number of employees at Computech with the job title of sales manager. So our criteria range is the company. Our criteria is Computech. Criteria range 2 is the job title. Criteria is sales manager. Close the bracket, hit enter, and there are 3 sales managers at Computech. And we can see there's one, and there's the third. And then finally, we want to count the total number of employees at Computech with the job title of sales manager and less than 9,000 in sales. So equals COUNTIFS. Criteria range 1 is the company. Hopefully you're getting the idea. Repetition is the best way to learn. Criteria is Computech. Criteria range 2 is the job title. Criteria is sales manager. And finally, criteria range 3 is the sales. And the criteria is what we have in cell H16. Close the bracket, hit enter, and we get a result of 2. And if I highlight those in the table, you can see that 2 of them have less than 9,000 in sales. And then the final one, I've just got 2 examples here because it works exactly the same, is average ifs. So this is if we want to calculate averages for multiple pieces of criteria. So this time we just want to work out the average of the sales for Computech. So our average range is going to be the sales. Our criteria range is going to be the company, and our criteria is going to be Computech. Close the bracket, hit enter. There is our average. Let's finish off the set and do the final one, average ifs. This time we're working out the average sales for people who work at Computech with the job title of sales rep. Average range is this range just here. Criteria range is this range. Criteria 1 is Computech. And then finally, criteria range 2 is the job title, and the criteria is sales rep. Close the bracket, hit enter, and we have our result. So hopefully you can see there how useful these functions could be. In fact, both COUNTIFS and SUMIFS have been voted amongst Excel users as 2 of the most useful functions. Give them a practice. Hopefully we've repeated this enough times that they are now solidified in your brain. Check them out, have a play around, and I'll see you in the next lesson. In this lesson, we're going to talk through 2 other logical functions, IFERROR and IFNA. And both of these are what we classify as error handling functions. And that's exactly what they do. They help us handle errors in formulas. So I'm going to show you how to use both of them, and we'll just walk through what the difference is between them, because there isn't too much of a difference. Now, we're using our employee data again. But this time, notice in column H, we have a lot of NA errors. Now, why do we have these errors in here first of all? Well, if we click on the first cell and take a look in the formula bar, I can see that I'm using the IFS formula, and let's just check through what this formula is doing. So the first logical test is testing if G4 is equal to J4. So that looks about right. So if G4 is equal to J4, then we want it to output the bonus of 3,000. That looks fine to me. What about the next logical test? Well, this time it's saying if G4 is equal to J5, output the result in K5. Again, that looks to be correct. But that's where the formula ends. So this formula is only accounting for employees that have received a job rating of 4 or 5. Anybody who's got 3, 2, or 1 isn't accounted for in this formula. And that is why when we've copied this formula down, anybody who does have a job rating of under 4 has an NA error, because the formula can't reference the job rating because we haven't told it to. Now, maybe in this example, only the people with a job rating of 4 or 5 are going to get a bonus, and that's why we've done this. But when we've constructed our formula, we've been pretty surprised that we have all of these NA errors appear in the cells. Why doesn't it just say nothing? Well, that is because we need to tell the formula that we don't want anything in the cell if there is an error. So basically what I want it to do here is wherever it finds NA, I want it to just have a blank cell because those people aren't getting a bonus. Now, this leads me on nicely to the difference between if NA and if error. Both of these are formulas that will handle errors, but the if NA formula can only be used when you have NA errors in cells. There are lots of different types of errors that we can get in cells in Excel, and if we try and handle those with if NA, it's not going to work. It only deals with specifically NA errors. Whereas if error will deal with any error. It doesn't matter what it is. It could be an NA, it could be a div, it could be a value, it could be a name error. If error is kind of your catch-all. So let's start out with if NA. I'm going to go up to the formula bar and we're going to edit this formula and we're simply going to add if NA on the front here. Now if NA only has 2 arguments, value and value if NA. So the value in the cell is being generated by this formula. So we need to click at the end here, comma. We now just need to specify what we want to have in the cell whenever it comes across an NA. Now I want this cell to be blank, so I'm going to put in 2 quote marks. You could put in here some text, something like no bonus. I just want a blank, so 2 quote marks, close the bracket, hit enter, and then we can simply double click to recopy that down, and now this looks a lot better. And I would always recommend that if you do have things like NA errors in spreadsheets, that you do add error handling in. Because if you send this spreadsheet to somebody else and they see all of these NA errors all over the place, they might not necessarily know why those NA errors are there. They don't know that it doesn't really matter. So it's a lot better for you to handle them before you send this out to anybody. And just to quickly show you if error, it does work in exactly the same way. So if we type if error on the front here instead, you can see that we have exactly the same arguments. So value and value if error. So this time I'm going to say I want to have no bonus in the cells instead. Hit enter, and then we can double clickety click to copy that down. Those errors are now handled and our spreadsheet looks a lot cleaner. In this lesson, we're going to take a look at how we can combine logical formulas with conditional formatting. So you can see here on this spreadsheet, we have some data about some students. So we have the student name, we have their student ID, the course that they're taking, and the block where they're located. So these might be blocks at a specific university. Now, what I want to do here is in cell C3, I want to be able to select a student name from a drop-down list, and I want it to highlight in the table below so I can easily find them. Now, of course, we're just using a very small data set here. This could be a data set that contains hundreds, even thousands of rows. So the ability to be able to highlight and immediately find what you're looking for is extremely useful. Now, we can do this using a combination of data validation, conditional formatting, and logical functions. Now, the first thing I want to do here is I want to set up my little data validation dropdown. And this drop-down list is just going to contain all of the names of the student. And in addition to that, I want to set this spreadsheet up so that when new students get added to the bottom here, not only does the drop-down list update, but also any of the conditional formatting that I've set. Now, to make this truly dynamic, we need to put our data set in a table. Control D. Yes, my table has headers. Let's click on OK. And I'm going to remove the table style, and I'm just going to apply this green table style, and I'm going to turn off banded rows. Another thing I'm going to do is I'm going to give my table a name. So on the table design ribbon in the properties group, instead of just the generic table 1, let's change this to students so it's easy to identify the table. So now we have our list of students. I want to create my data validation drop-down list. Now all of the student names in here are unique, so this is a fairly straightforward process. We just jump up to the Data tab, across to Data Tools, and click the drop-down and Data Validation. On the Settings tab, we want to create a list, and then we just need to provide the source of our list items. Now, we want the student names in the drop-down, so I just want to select all of the student names from here. Let's click on OK, and now you can see we have a nice little drop-down where we can select different students from a list. So we've got our table, we've got our drop-down. We now need to add conditional formatting so that whichever student we've selected highlights in the table below. Now for this, I'm going to select all of the student names. We're going to go up to the Home tab, into conditional formatting, and we're going to create a new rule. And we're going to use a formula to determine which cells to format. Now the formula that we want to use in here is we want to say equals, and the thing that we're checking for is the student name in the table. So we need to select the first student name in the table. Now notice that by default it's put in an absolute reference. That's why we have these dollar symbols just here. Now if I was to leave this as an absolute reference, when we apply the formatting, it's only going to apply the formatting to cell B9 because we've locked it in place. So what we need to do here is we need to remove that second dollar symbol. So what this now basically says is always look in column B for the student name, but let the formatting travel along the rows because it's not locked to a specific cell. So if the name in the cell equals whatever we've selected from the drop-down list, and for this cell reference, we can leave that as an absolute reference because it's never going to change. We can then choose what formatting we want to apply. So I'm going to say that I want bold formatting. I'll change the fill color to, let's go for a green, and let's put a border around the outside. I'm going to do a thin border and we'll make that an outline border and click on OK and OK again. And check out what happens immediately. It's picked up Lucinda. And if we change the student name in the drop-down, you can see that that moves and highlights the relevant student. So this is a great way of combining data validation, conditional formatting, and logical formulas. And the cool thing is, because we put our data in a table, if we were to add a new student to the bottom, so let's say Ian Kane, he's studying art and he is in the South building. Notice that the table auto expands to account for that new record. And if we go back up to our data validation drop-down list, you can see that he's automatically been added into the bottom. If we select him, the conditional formatting applies. So once we've set this up this way, we're pretty much good to go. We won't need to make any other changes when we start adding more students into the table. It's time now to do exercise 3. And in this exercise, we're going to practice some of the skills that we've learned in this section of the course. So you can see here that we have a table of data. This lists out some athletes, the country that they're from, their gender, and also the medal they achieved, either bronze, silver, or gold. And what we need to do is complete the prize money in column E. And you can see that we have a little table just here that shows the different medals and the prize money attributed to each. So I'd like you to use either nested if statements or the IFS function to complete the prize money column. Once you've done that, I'd like you to move on to the two tables below and complete the results using the criteria. So for this first table, we need to calculate the number of athletes that are from the USA. I'd then like you to find the number of athletes that are from Australia and who are female. And then finally, I'd like you to find the number of athletes who are from the UK, male, and achieved a silver medal. And then finally, at the bottom, I'd like you to work out what the total prize money is for everybody from the USA. And then finally, the total prize money for all female Canadian athletes. So think about the formulas that you'll need to use to complete these last two tables. If you'd like to see the solution to this exercise, download the solutions file from the exercise files folder. I hope you get on okay with that, and I will see you in the next section. In this section of the course, we're going to move on to taking a look at a very important set of functions, and those are lookup functions. Consistently voted the most popular and most used functions in Excel, VLOOKUPs help us look up information in a table based on a corresponding value. And in this lesson, we're going to start out by taking a look at VLOOKUP. Now, VLOOKUP is one of the oldest lookup functions. It's a much loved function, but it does have its limitations. And those limitations have been dealt with recently with the release of a new lookup formula called XLOOKUP. And we're going to be taking a look at XLOOKUP a bit later on in this section. So let's start out by taking a look at VLOOKUP, because this is still a really popular function and you're going to need to know how it works, because you're going to find that so many spreadsheets, particularly older spreadsheets, will probably contain this formula at some point. Now, the first thing to remember about VLOOKUP is that it has two different incarnations. We have VLOOKUP exact match, and we also have VLOOKUP approximate match. So let's deal with exact match first of all, because this is the one you're more likely to come across. Now, what we have in this first spreadsheet is we have a small list of part numbers. And notice that in columns B and C, where we have the description and the unit price, we don't have any values in there. Now, we have another spreadsheet at the bottom called Parts Catalogue. And this is a master list of all of the parts. So maybe we are a supplier of different parts. We have all of the parts listed in the first column, then we have the description, and then we have the price for each part. So effectively what we want to do is we want to look up the part number in the parts catalogue in this first column, and we want it to return the description and the price. So this is where we can use VLOOKUP. Now, I would recommend that when you're using VLOOKUP, that you do put your data into a table. So I'm going to go back to my parts catalogue. I'm going to click and I'm going to press Control T. Yes, my table has headers. Let's click on OK. And once again, I'm just going to remove the table style. And I'm going to give my table a name. We're going to call it Parts Catalogue. Remember, with these table names, you can't have any spaces. So let's go back. Let's type in equals VLOOKUP. Now, if you're wondering what the V part of VLOOKUP stands for, it's vertical, because we also have an HLOOKUP we can use, which stands for horizontal lookup. And again, we'll look at that in another lesson. Now, VLOOKUP has 3 mandatory arguments and 1 optional at the end. The first argument is the lookup value. So this is, what do we want to look up in the table? Well, I want to look up the part number, so what we have in cell A5. Table array, where do I want to look this up? I want to look up the part number in the parts catalogue table. Now, because we've put this in a table, I can simply start to type in the name of the table and it's going to come up underneath. So this is one of the reasons why I like to put the data in a table. If we hadn't have done that, we would need to jump across to the parts catalogue worksheet and start selecting the cell range. And that can be a little bit awkward. So it's much easier just to name the table and then you can pick it up from the original worksheet. Comma. Column index number. Which column do we want to return? Now, we want to return the description, and the description column in the parts catalogue is column number 2. VLOOKUP numbers columns from left to right. So the column index number is 2, comma, and this is where we get to specify if we're doing an approximate or an exact match. Now, we want to exactly match the part number in the table. So we want a false on the end here. Now, remember, with trues and falses, you can replace these with 0 for false or 1 for true. I'm going to leave it on false. Let's close the bracket, hit enter, and you can see that it's returned that description. Now I'm going to double click to widen out this column, and then we can simply drag this formula down. Now notice here that we have an NA error, and we spoke about these in a previous lesson. Now, why are we getting this error? Well, I'm going to guess that this part number doesn't exist in the parts catalogue. So if we jump back to the parts catalogue, I'm going to do a quick search in this column for part number 12345. So let's press Control F. What am I looking for? 12345 is the part number. Let's say find next. It can't find what I'm looking for. So I can safely assume that somebody's typed this part number in wrong. Now I could choose to delete that row, or I could just use error handling to deal with this. Now it is an NA error, so I can use if NA. I could also use if error if I wanted to. And if it can't find the part number, I just want it to say part not found. We'll add that onto the end, hit enter, and now when we double click to copy this down, that now makes more sense. Let's do another VLOOKUP for the unit price. Now this time we're looking up the information in column number 3. So part number is column 1, description's column 2, price is column 3. So this is basically virtually identical to what we just did. We're just changing the column number that we're returning. So our lookup value is the part number, our table array is the parts catalog table. The column index number this time is 3, and we're doing an exact match. We can have false on the end there or simply a 0. Close the bracket, Control Enter, and then when we double clickety click to copy this down, it's going to return the correct results. Again, we have NA in there, so we'll want to add in some error handling. So let's use if error this time because we haven't used that yet. So I'm going to add if error in there, and this time it's going to say price not found. Close the bracket, hit enter, and double clickety click to copy that down. So that is a very simple VLOOKUP exact match. Let's take a look at a different situation. I'm going to jump across to this other worksheet that I have here, and we're going to use the approximate match argument. Now, approximate match is when you're looking up something that doesn't exactly exist in the table that you're looking it up in. So for example, you can see here that we have some tax brackets. We have a low end value, a high end value, and then a marginal tax rate. And what I want to do is I want to look up somebody's annual salary in this table, and I want it to return the marginal tax rate. But if you take a look at this first salary of 55,000, if I take a look at these values in my table, you can see that I don't exactly have 55,000 written out in a cell. 55,000 is going to fall somewhere in this bracket just here. So we can't do an exact match because it doesn't exist exactly in the table that we're looking it up in. This is where we need to use an approximate match. Now, this time I'm not going to convert these to tables because they're small data sets on the same worksheet. So let's go straight in with our VLOOKUP. Now, our lookup value is the salary. Our table array, well, we're looking it up in this table over here. Now, because I want to drag this formula down, I need to press F4 to lock those cell references in place. The column index number, well, I'm returning the marginal tax rate, which is column number 3. And this time we're doing an approximate match, so I need a true on the end there. Close the bracket, Control Enter, and then we can copy this formula down, and we should find that these values are correct. So let's just do a spot check. Annual salary 55,000, that's going to fall within this range. The marginal tax rate is 25%. If we take a look at 90,000, that's going to fall within this range, and the marginal tax rate returned is 28%. So that is how you construct a VLOOKUP and the difference between VLOOKUP approximate match and VLOOKUP exact match. In the previous lesson, we saw how we can do a VLOOKUP, and I mentioned that the V part of VLOOKUP stands for vertical. Now, we have another lookup function called HLOOKUP, and as you might imagine, the H stands for horizontal. So the difference between HLOOKUP and VLOOKUP is that you use one if your data is organized vertically, and the other if your data is organized horizontally. Now, the format that most data is in is vertical. For example, this data set that you can see on this worksheet, this is vertical data. It's where we have our column headings running across the top here, and then we have our rows or our records. And this is by far the most common. But occasionally you will come across a spreadsheet where the data is organized horizontally. So let me show you what that looks like. What I'm going to do is I'm just going to grab this data set and I'm going to flip it around the other way. So this is also a good opportunity for you to see how to transpose data, which effectively will change the layout. So I'm going to click in my data, Control A to select everything. I'm going to press Control C to copy. I'm just going to go underneath this table, click in a cell, and then I'm going to transpose this data. Now, if we go up to the lower half of the paste button and open up Paste Special, this is where we have our transpose feature. Now, if I click on this and click on OK, it's going to flip that data the other way around. So now you'll notice that we have the column headings in the rows as opposed to in the columns. So we have our titles of our movies running across the row, the year running across the row, so on and so forth. Now, if I wanted to perform a lookup using data that was organized like this, I would need to use HLOOKUP. Because when we use a VLOOKUP, the third argument is the column reference number. So it's asking us to specify the column that we want to return. Now, with HLOOKUP, we need to specify the row that we want to return as opposed to the column. So let's take a look at what that would look like. I'm going to jump across to the HLOOKUP worksheet. And what I want to be able to do here is select a movie from the drop-down list and have it return the year, what it's rated, and the genre. So we're going to start out by creating a data validation drop-down. So let's go to data, click the drop-down next to data validation and choose data validation from the menu. We want to create a list, and my source for the list I'm going to find on the movie database worksheet, and I'm going to choose the titles of all of the movies. Click on OK. So now I should find that I have a drop-down list that contains all of those movie names, and I can use this to select whichever movie I'm interested in looking at. So now I want to construct an HLOOKUP formula. So let's type in HLOOKUP. And what you'll notice is that the arguments are pretty much exactly the same as when we're using VLOOKUP, except the third argument here is row index number as opposed to col index number. So our lookup value is going to be the film that we select in cell B5, comma, the table array. Now, I haven't named my table. So what I would need to do here is jump across to Movie Database, go down to here and select the entire table. Now, of course, I can do that, but it's quite a long table, so I'm going to come out of here. Instead of creating a table, I'm going to turn this into a range. So let's click Control A. I'm going to go up to the name box just here, and I'm going to give this range of cells a name. And we're going to call this movies and hit enter, because you can use named ranges in lookup formulas as well. So let's go back to our HLOOKUP. Our lookup value is the movie name. The table array, well, I want to use the range that I just created. Now I could start to type in the name of the range. You can see there it is, movies. Alternatively, if you can't remember what you called it, you can press the F3 key and it will show you any named ranges you have in your workbook. So I'm going to select movies. Let's click on OK. Row index number. What row do I want to return? Well, I want to return the year. I can't remember which row that is. Let's quickly jump back across and have a look. So the year is row 2. Let's go back to our formula. Now I'm going to get rid of that HLOOKUP. And we're going to say we want to return the second row, and then we can do an exact or an approximate match. Now I want to exactly match the film name in that range of cells, so we want a false on the end here or 0. Let's hit return, and you can see it's returned the year 2016. And if we change the movie name, so let's do something at the top here, La La Land, again that's 2016. Let's check it in the movie database, La La Land, and the year is 2016. Now, with these formulas, you can't necessarily copy these down. You're going to get some NA errors. Because if we take a look at this formula, we can see that it's looking up cell B6, which is currently blank, in the movies table, and it's trying to return row 2 again. So this isn't correct. So if we escape out of there, I could make this a little bit better by locking the cell reference B5 in the formula so it doesn't move. So let's do that. Let's press F4. Hit enter. Now it's still not going to work properly because it's returning row number 2 every single time. But I could simply go in, edit these formulas and change the row. So we're looking for rated and genre. So rated is row 3 and genre is row 6. So I'm very quickly just going to come into this formula. We'll update this row number to 3 and we'll update this row number to 6. So now when I change this to something else, we get all of the results that we're looking for. So that's the difference between VLOOKUP and HLOOKUP. It really does just relate to the way you have your data organized on your page. So far in this section, we've been taking a look at how we can use VLOOKUP and HLOOKUP to look up information in a table. And I did mention in the very first lesson that VLOOKUP, whilst popular, does have its limitations. And that's exactly what we're going to cover in this lesson. We're going to explore the limitations of VLOOKUP, and I'm going to show you how you can combine two formulas together to perform a more flexible lookup. Now, once again, we're starting with some very basic data. I have some categories. I have some apps that belong to those categories. And we have the amount of revenue that this app has generated and also the profit. So these might be mobile apps. And what I want to do is I want to be able to select an app from the list over here and have it return the category, the profit, and the revenue. So let's set up our data validation drop-down list first of all. I'm going to go to the Data tab, click the drop-down Data Validation. We want a list just here, and the source for our list, well, we want all of the apps. So let's select this range and click on OK, and now we can choose which app we're interested in from the menu. Now let's first try and do this lookup using VLOOKUP, because that's really going to highlight to you the limitations. So let's type in equals VLOOKUP. Our lookup value, well, we're looking up the app in cell H5. I'm going to press F4 to lock that in place. Comma, table array, where are we looking up this app? Well, we're looking it up in this table over here. Again, I'm going to press F4 to lock that in place. Comma, column index number. Now I want to return the category, and the category is in column number 1. So let's type in 1. Am I doing exact or approximate matching? Well, I want to exactly match the application name in the table, so we're doing an exact match. We want a false or a 0 on the end just here. Now let's hit enter. I'm getting an NA error. So why is that? Well, this is related to this argument here, the column index number. When you're using VLOOKUP, it can only return values that are to the right of the lookup value. So my lookup value in this case is bejeweled, and bejeweled is effectively in the second column. So if I wanted to return the revenue or the profit, that would work absolutely fine because these two columns are to the right of where the lookup value exists. But because in this case I want to return the category, which is to the left of it, it can't do it. And that is the limitation of VLOOKUP. You can't have a lookup value in the table and return values that are to the left. Everything always has to be to the right. So VLOOKUP tends to work best when your lookup value is in the first column of your table. Now, because of this limitation, we need to explore an alternative method when it comes to performing more flexible lookups. And to do this, we can combine two functions in Excel, index and match. So let's first take a look at what these two functions do individually, and then I'll show you why they're so powerful when you combine them together. So let's start out with index. If we type in equals index, notice here that we have a few different arguments. Now there are two different versions of index. We're using the top one just here. Now my array, the way that I remember this is the array is always the range of cells where you're going to find your answer. Now we're looking for the category, so I'm going to select the category array, comma. Now the next argument is the row number. I need to tell it the row number to return. So if I'm looking up bejeweled, I can see that that is 1, 2, 3. That's the fourth one in the list. So I want it to return row number 4. Close the bracket, hit enter, and it returns the correct category for the app bejeweled. But this is a very manual process. I don't want to be counting down rows in order to get my answer. I have a very small data set here, so it's not too much of a problem. But imagine if you had a data set with thousands or hundreds of thousands of rows. That's just not going to be plausible. So with that in mind, let's take a look at what the match function does on its own. So if we type in match, this function has 3 arguments. The first one is lookup value. So we're looking up the app. The next argument is lookup array. So where are we going to find this app? Well, we're going to find it in the app array, and then we need to specify the match type that we're doing. Now, I want to exactly match the app name in the selected range. So I'm going to put 0 in here, close the bracket, hit enter. Check out what it returns. It returns the row number. So we can basically combine this match with index to automate our lookup. So let's go from the top. We're going to type in index. Our array is where we're going to find our answer, which is this category array. When we get to the row number argument, we're going to go straight into our match. Our lookup value is Bejeweled. I'm going to press F4 to lock that in place. Where are we going to find that? Well, we're going to find it in the apps list. And then I'm doing an exact match. And I think I'm going to lock these cell references as well. So let's just go back and press F4 to lock all of these because we don't really want anything to move around. Close the bracket for match and close the bracket for index. Hit enter. We get the result that we're looking for. Let's do it again, but this time we're going to find the profit. So we're going to type in index. Array is where our answer is going to be. So this time we want to select the profit array. Let's press F4. We go straight into our match. Our lookup value is Bejeweled. Where are we going to find it? We're going to find it in our apps list. And we want to do an exact match. Close off match, close off index, hit enter, and we get our answer. And I'm just going to apply some accounting format. Let's do the final one. Hopefully you're getting the idea here. Index, where is our answer? Well, this time we're going to find it in the revenue array. F4 to lock. Straight into match. We're looking up Bejeweled. We're looking it up in the apps list. And we're doing an exact match. Close off match, close off index, hit enter, and we get the correct result. So if we take a look at this row for Bejeweled, I can see that it's in the game category. The revenue is 18,750 and the profit is 984.90. And if I change this to something else, we should find that everything updates perfectly. So now we're looking at the record for OneDrive. So index and match combined together are a much more flexible way of doing lookups because it doesn't matter where your lookup value exists in relation to the columns that you want to return. So bear this in mind if you're trying to use VLOOKUP and having problems. It might be that you just need to switch to index and match. So far in this section, we've seen how we can perform lookups using VLOOKUP, HLOOKUP, and by combining the index and match functions. And it's now time to move on to talking about the most modern of lookups, and that is XLOOKUP. XLOOKUP was introduced in Excel 2019, and the whole concept behind XLOOKUP is to really provide an easier way of doing essentially the index and match formula. Because one thing you need to understand is that index and match wasn't invented to do lookups. They were two separate functions that people ended up mashing together in order to get around the limitations of VLOOKUP. So the index and match combination for doing lookups was really a workaround or a hack, if you like. So Microsoft finally did deal with this by introducing XLOOKUP, which makes the whole process of flexible lookups a lot easier. We don't have any of the limitations that we have with VLOOKUP, and it's a lot easier to construct and remember than index and match. And we're also going to take a quick look at XMATCH, which came along with XLOOKUP. So let's start out by using XLOOKUP to do a very similar lookup. Again, we have our categories, our apps, our revenue, and our profit. Now, I've already gone in and created the data validation dropdown. You've seen me do this quite a few times already in this course. I didn't think I needed to waste time and show you that again. Now, we're going to do the same thing. We want to return the category based on the app that's been selected. So let's use XLOOKUP. Now, one of the other advantages of XLOOKUP is that we now have more arguments to give us even more flexibility. Now, notice that the final 3 arguments, those are all optional because they're contained within square brackets. So let's just do a very basic XLOOKUP first of all, and then we'll explore some of the other options. And I think you'll find this so much easier than index and match. Now, the first argument here is lookup value. What are we looking up? Well, we're looking up whatever we have in cell H5, F4 to lock, comma. Where are we looking it up? What is the lookup array? Well, we're looking up Google Docs in the apps list, F4 to lock, comma. What do we want to return? We want to return the category. So we just simply need to select the category array. That is literally it. So much easier than remembering that index and match formula. Let's hit enter. It returns productivity. Now again, this isn't a formula that we can copy down. If we copy this down, we're just going to get productivity again, but it is fairly straightforward just to edit this formula. Because H5, that's going to be the same. The cell range B6 to B16, that's going to be the same. It's only this final group of cell references that's going to be different because we want to return a different column. This time we want to return the profit. So I'm just going to switch out these cell references for these ones just here. Let's press F4, hit enter, and we get our answer. Again, let's apply some accounting formatting. So if we take a look at Google Docs, we can see that that is in the productivity category and the profit is 1,166. Now let's take a look at some of those optional arguments when we're using XLOOKUP. And to demonstrate this, I'm going to make a quick change to this table. Now let's say that we have 2 occurrences of Instagram in this table. So effectively we have a duplicate lookup value. So let's select Instagram from here. You can see it's updated, so the category is game, which is correct, and the profit is 984.90. That looks correct. Let's just finish this off by adding in the revenue. So let's type in XLOOKUP. Lookup value is Instagram. Our lookup array is the apps list, and our return array this time is the revenue. Let's close the bracket and hit enter. So this looks good so far, but it's returning the details for this row just here. What if I want it to return for this one just here? Now the reason why it's returning this one is because XLOOKUP will start looking from the top to the bottom. So it's going to look down the apps column for the first occurrence of the word Instagram, and it's going to return those results. So it's always going to return the first one in the list. What if we wanted to return this one instead? Well, we can do something slightly different. Let's delete out what we've done and go back into XLOOKUP. Our lookup value is Instagram. Lookup array is still the apps list. The return array is going to be the category in this case, comma. We now move into our optional arguments. Now the first one here is we can specify what we want it to say in the cell if it can't find Instagram in the list. Now you don't necessarily have to add anything here, but you could say not found. The next argument we move on to is match mode. So again, this is if we want to do an exact match, if we want to do an exact match or next smaller item, exact match or next larger item. Those would be more relevant if you're looking up values, or we can do a wildcard character match. Now I want to do an exact match. That is the default. You don't have to put anything in here. So we'll add a 0 and move on to the last argument. Now this is where I can tell the XLOOKUP formula that I want to look from the bottom up as opposed to the top down. So the default is to search first to last, but I could say search last to first instead. And that's going to put a -1 on the end. If we close the bracket, hit enter, you can see now it returns the result that I'm looking for. So now it's looking from the bottom up, it finds Instagram and returns the correct category. So I've just gone ahead and I've modified the cell references so that these are correct. So don't forget that you have those additional arguments when you're using XLOOKUP. Now, a common question that I get at this stage is, okay, that works well, but what if I had 3, 4, 5 duplicates, 5 occurrences of Instagram in this list? How would we do that? Well, we can use an entirely different method to do that, which I'm going to show you in the next lesson. Let's just finish off this lesson by taking a quick look at XMATCH as well. So XMATCH is similar to match. So let's delete out revenue and we're going to type in equals XMATCH. Now here we've got a few arguments. Our lookup value, let's say, is Instagram. Our lookup array, well, we're looking for that in the apps list. We then get to choose our match mode. So I'm going to do an exact match, and then we can choose if we're searching first to last or last to first. So let's just do first to last, close the bracket, hit enter, and it's showing us a dollar amount. I'm going to change the formatting to general. You can see that this returns the row position again. So it's looking first to last. Instagram is the 4th item in this range. So this is very similar to using match. It just has some additional options. So that's how you can use the new XLOOKUP and XMATCH to perform flexible lookups. In the last lesson, we saw how we can use the new XLOOKUP and XMATCH functions to perform flexible lookups. And I mentioned that if you have duplicate lookup values in your table, you're going to have to think a little bit outside of the box in order to get your formula to return exactly what you want it to return. So what do I mean by all of this? Well, if you take a look at the data that we have on this worksheet, you can see that I have a little table of employee details. We have the employee's name, we have the department they work in, and they have the country that they live in. And just above, we have another small table with the employee name, the department, and we want to return the country. Now, notice that in this table, I've highlighted that we have 3 employees with exactly the same name. Now, that might seem a little bit crazy, but imagine if you're a global organization with thousands of employees, the likelihood of 2 people having the same name isn't so crazy. For example, you might have 4 John Smiths because that is a very common name. So if I want to look up the employee Olivia Moore, who's in the HR department, and return her country, I'm going to need to use some kind of lookup formula. So let's try doing this with a VLOOKUP. Our lookup value is going to be the employee name, comma. Our table array, well, we're looking it up in this table just here. I'm going to press F4 to lock that. Column index number, what column do we want to return? Well, I want to return the country, which is column number 3. And I want to do an exact match of the name. So we want a false or a 0 on the end there. Let's close the bracket and hit enter. Now it's returning UK. And if I look at this, this is completely wrong. Now, why is it returning UK? Well, the lookup value was Olivia Moore. So VLOOKUP will start at the top of the table. It will look down the column until it finds the first occurrence of Olivia Moore, which is just here. And it will return the value in the 3rd column, which is UK. Now, this Olivia Moore that we've got selected at the top here is not the same as this Olivia Moore. The one we're looking for works in the HR department, whereas it's returned the country for the Olivia Moore that works in the sales department. So we can't use VLOOKUP. What about XLOOKUP? Let's see if we have any more luck with that. Our lookup value is Olivia Moore. Our lookup array, we're looking up the employee name in the list of employees. What do we want to return? We want to return the country. Let's close the bracket, hit enter. Again, it's returning the UK because it's just looking for the first occurrence in the table of Olivia Moore. What if we double click to edit this formula and change the search mode? So I'm going to press comma a few times to jump to search mode, and I'm going to say search last to first. Let's hit enter. Now this time it's returning USA. And if I take a look at this, it's basically returning this record just here. And that's because I changed the search mode to search from last to first. So it's working from the bottom until it finds the first occurrence of Olivia Moore, and then it's returning what we have in column 3. So neither of those 2 methods are giving me exactly what I want. So how can we do this? How can we return this Olivia Moore sitting in the middle just here? Now we can use either VLOOKUP or XLOOKUP to do this, but we need to be a bit smarter about how we use them. Because what we effectively need to do is we need to create a unique reference in order to find the correct record in the table. Now if I take a look at the information up here, I could create a unique reference by combining the employee name with the department. So what I'm going to do is I'm going to add a column at the beginning of my table, and I'm going to call this helper. And let's just copy the formatting across so everything's nice and consistent. And I'm going to use concatenation to create a unique reference for each record in the table. So let's type in equals. What I'm going to do is I'm going to combine the value in this cell, the employee name, ampersand, which means join. We're going to join it with the value we have in column C. What I'm now going to get, if I copy this down, is basically a unique reference for each record in the table. Because now, if we look at the Olivia Moores, this one here is Olivia Moore HR, this one here is Olivia Moore Sales, and this one here is Olivia Moore Finance. So these are now unique. So what we can do in our lookup formula is reference this column as opposed to this column as our lookup value. So let's use VLOOKUP to do this. We're going to type in VLOOKUP, lookup value. Now our lookup value is going to be this cell combined with this cell. That's our lookup value. Table array. We need to include our new helper column in our table array, comma, column index number. What do we want to return? Well, we have an extra column now, so the column that we want to return is column number 4 because we want to return the country. And we're doing an exact match, so we want a false or a 0 on the end. Let's close the bracket, hit enter, check it out. We're now getting the correct result, Olivia Moore HR Germany. And if I was to change the department here to sales, it's going to return the correct result again. So by creating a way to uniquely reference each row in the table, we've managed to overcome the issue of having duplicate lookup values. And of course, if you don't want this helper column to show, there are numerous different ways you could deal with that. You could, in fact, hide the column. Or alternatively, if we backspace out of there, you could simply select the cells, Control 1 to jump into formatting, go to the number tab, and in the custom group, if you type in 3 semicolons, that will effectively hide the text within those cells. Now in this case it doesn't work too well because we have formatting just here, so the most appropriate method to use would simply be to hide the column. But that is a solution to a very common problem. Remember, you can combine as many fields together as you need in order to create a unique row reference. The choose function is one of the lesser known lookup functions, but it can be useful in many different situations. And I'm going to show you a couple of examples of how you can use choose. So in this first example, I have a list of employees and we have their job rating. And then we have a little table over in columns G and H that converts that rating to a class. So if they scored a job rating of 1, that's considered to be poor. Job rating of 2 is fair, so on and so forth, all the way through to the top rating of 5, which is considered to be excellent. So if I want to look up what their class is based on their job rating, I could use choose. So let's click in the cell. We're going to say equals choose. Now notice the screen tip here. It says choose a value or action to perform from a list of values based on an index number. And that's a really important point. Choose needs an index number in order to work. And an index number is a value like 1, 2, 3, 4. So you can't look up text using choose. So let's press the tab key. The first argument is index number. So I want it to look up the rating. And because this is a number, that's absolutely fine to use, comma. We then need to tell the formula what we want it to return. Now we're going to copy this formula down. So the first value in the list is poor. And I'm going to press F4 to lock, comma. Value 2 is fair, F4. Value 3 is good. Value 4 is very good. And then finally, value 5 is excellent. That's all we need to do. Close the bracket, hit enter, and then we can safely double click to copy this down, and it's going to translate those ratings based on what we have in this little table over here. So a really simple way to perform a lookup. Let's take a look at how we can use choose with another function to produce a different result. So over here, again, I have a list of employees, and then we have a team column, which is currently empty. And we have this small little table over here that says team, and then we have blue, red, green, and yellow. So let's say that it is our company's summer party, and we're trying to assign people to different teams to take part in a rounders game. And those teams are blue, red, green, and yellow. Now, we want to make the assignment random so we don't have too many strong players on one team. So to randomly assign these teams to our employees, we can use a combination of choose and rand between. Now, the rand between function generates random numbers. So let's take a look at that on its own first of all before we combine it with choose. So we're going to go with rand between. We need to choose a bottom and a top number. Now, because we have 4 teams, the bottom number is going to be 1 and the top number is going to be 4. So when I close the bracket here and copy this formula down, it's going to randomly assign a number between 1 and 4 to each employee. Now, in order to get those to say blue, red, green, yellow instead of numbers, we can combine it with choose. So let's double click. Let's go to the front of the formula and add choose onto the beginning. So our index numbers are being generated by the rand between formula. So all we need to do is provide it with the corresponding values. So whenever there's a 1 in the cell, they're going to be assigned to the blue team. Whenever there's a 2, they're going to be assigned to the red team. Whenever there's a 3, they're going to be on the green team. And whenever there's a 4, they're going to be on the yellow team. Let's close off choose, hit enter, and then we can double click to copy that down. And we now have people randomly assigned to different teams. So those are a couple of use cases when it comes to using choose in order to do lookups. The switch function is very similar to the choose function and can be a good replacement for something like VLOOKUP or XLOOKUP. So in this lesson, we're going to take a look at an example of how you can use switch. Now, what we have here in column D are some movies listed out. In column E, we have a ratings column, which is currently blank. And then in column F, we have the IMDb score for that movie. And what I effectively want to do here is complete the ratings column using the IMDb score. And if we take a look over on the left-hand side, we have a little table here that shows the rating and the score that's attributed to that rating. Now, of course, this is a scenario that is kind of perfect for some kind of lookup function like VLOOKUP or XLOOKUP. And it's worth noting that the switch function, despite the fact that it is really a lookup function, you're not going to find it under the lookup and reference group of functions in the functions library. You'll actually find switch underneath logical. Now, before we get on to working with switch, let's take a look at how we would do this if we were using XLOOKUP. And then we can do a good comparison between the two. So we're going to type in XLOOKUP. Now the lookup value is going to be the IMDb score, comma. Where are we looking this up? What is our lookup array? Well, our lookup array is going to be wherever we're going to find this score. So this is our lookup array, B3 to B7. Now we're going to copy this formula down, so we don't want those cells moving, so F4 to lock. What is our return array? Well, we want to return the rating. So we need to select A3 to A7, F4 to lock, and then we close off our XLOOKUP. Let's hit enter. Let's copy this down, and we get exactly what we're looking for. Now, of course, the disadvantage with this, again, is if we were to delete this table or delete the values out, we're going to get NA errors in column E. So one advantage that the switch function and the choose function also have is that we don't necessarily have to have what we're looking up in a table or a list, because we define our values from within the formula. So let's do the same thing, but this time we're going to use switch. So Control-Shift down, just delete out everything that we have in there, and this time we're going to use switch. Our first argument is the expression. So this is basically, what are you looking up? So I want to look up the score, comma. Now I get to define the different values. So the first value I need to define is a score of 9. If it finds a score of 9, it's going to return the word excellent. If it finds a score of 8, it's going to return the words very good. 7 is going to be good. 6 is okay. And finally, 5 is poor. And close the bracket. So now if I hit enter and copy this formula down, it's going to produce exactly the same result as the XLOOKUP. The only difference here is that if this data gets deleted out of this table, it has absolutely no effect on the values in column E, because we're defining our values that we're using as opposed to referring to them via cell references in an external table or some kind of list elsewhere on the worksheet. So that is the advantage that switch, and to a lesser extent choose, have over XLOOKUP and VLOOKUP. So you might find there are certain scenarios where switch is going to be extremely useful to you, particularly if you don't want big long lists of data or tables of data on your worksheet. You just want the results. It's time now to do exercise 4. And in this exercise, we're going to practice some of the skills that we've learnt in this section of the course. Now, in this section, we were taking a look at lookup functions. And you can see here I have some data, again, that lists out athlete names, their bib number, the event that they did, in this case the full marathon, and which route they took, either East Loop or West Loop. And then we have the position that they finished in. So the first thing I'd like you to do is I'd like you to create a data validation drop-down list in cell H3 that lists all of the athletes. I'd then like you to use a lookup function of your choice, so you can use any lookup function to return the bib number, the route, and the position of whatever athlete has been selected in the drop-down list. And I'd like you to add error checking into the formula to account for any NA errors that may occur. That's all I need you to do. If you'd like to see my solution to this exercise, then please download the solution file in the exercise files folder. That's it for now. I will see you in the next section. In this section of the course, we're going to take a look at some of the options that we have when it comes to sorting and filtering data. Because this pair of extremely useful utilities really do come in handy when we're dealing with large data sets. And in this lesson, we're just going to start out by taking a look at a basic multi-column sort. So you can see here I have a reasonably large data set. If we press Control down arrow, that's going to jump us to the last row. So you can see we have just over 1,000 rows of data. Control up arrow to jump to the top. Now these records have been entered in no particular order. So when I'm looking at this data set and I'm trying to extract information or interpret what I'm looking at, it's quite difficult because it's a bit all over the place. Now, one of the methods that we can use to help us organize this a bit better is sort. And you might be familiar with sorting on columns. For example, if I wanted to sort this data set by the department, I could click the drop down at the top here and choose Sort A to Z or Z to A. Alternatively, I could go to the Data tab, and in the Sort and Filter group, I have options in here as well. So I can sort A to Z or Z to A. So if I sort this column A to Z, it's going to put the departments in alphabetical order. So now I have all of accounting at the top. Then we move on to engineering, so on and so forth. Finance is the next one. So it groups everything together, makes it a little bit easier to read. Now I'm going to undo just to put those records back to how they were. Because what I want to do here is I want to do a multi-column sort. So I want to sort by department, then I want to sort by business unit, and then I want to sort by country. Now, if you want to sort on multiple columns, again on the Data tab, we have a big Sort button just here. Now, when we click on this, it's going to open up the Sort window, which allows us to sort by different columns. So the first thing I want to do here is I want to say sort by department. I want to sort on the cell values. Now, if we click the drop down, notice we have different options in here. We can sort by cell color, font color, or conditional formatting icon. And we're going to be looking at some of these in a moment. For the time being, let's just choose cell values, and then I can choose if I want to sort A to Z, Z to A, or use a custom list. And we're going to be looking at custom list in the next lesson. So I'm going to say, let's say Z to A this time, and then I can choose add a level and say then sort by whichever column I choose. So we're going to sort by department, then by business unit on the cell values, and we'll do those Z to A as well. Let's add one more level because then I want to sort by the country, and we're going to sort those on the cell values, and to keep things consistent, Z to A. So when I click on OK, you can see that's exactly what it's going to do. So it's sorting by department because we're doing Z to A, we have sales at the top. Then it's sorting by business unit, again, we're doing Z to A, and then it's sorting by country. So very easy to do a multi-column sort. Now, what if, and I'm just going to select a few rows in here, and I'm just going to apply some formatting. So let's make these a light yellow color. So what if I have a spreadsheet, a data set that has rows that contain background fills? Maybe somebody has gone through this spreadsheet and they've highlighted certain records. Well, we can sort by cell background color as well. So once again, if we go to the Data tab, click on Sort, and I'm going to delete out the current sort that I have applied. So I'm just going to delete all of those levels. This time I'm going to add a level, and I could choose any column here because the formatting runs across all columns. So let's just go for the full name. This time I want to sort on the cell color. Notice as soon as I select that, I get to choose the cell color that I want to sort on, and it will pick up on the background fills that you have applied to your data set. Now, because I only have one, that's this yellow, I can select it, and then I can choose if I want the rows that have this background fill to be on the top or on the bottom. So I'm going to say on the top, let's click on OK, and it's going to sort this list based on the background fill of the cell. And this would work the same if we had font that was a different color. So let's apply some red font to these records just here. And then again, if I want to sort, I can go back to my sort dialog box. I'm going to delete out this level. Let's add another level. I can choose any of the columns to sort by because the formatting runs across all columns. So let's go for job title. This time I can sort based on font color. And notice that it picks up that I have red font used in my workbook. And I could, if I wanted to, choose to sort these so that anything coloured in red is at the bottom. Let's click on OK. And now if we press Control down arrow to jump to the bottom, we should find those records are sorted and are right at the end of the table. So very, very simple to do a multi-level sort when you're working with lots of data. In the previous lesson, we saw how to do a sort on a data set using multiple columns. And in this lesson, I'm going to show you how you can use your own custom list to sort your records. So what do I mean by a custom list? Well, a custom list is basically a list that you set up, and you can then use it to define how your records are sorted. For example, we have our data set just here, and if we go to the department column, if I click the filter drop down, you can see that in this data set we have 7 different departments. Now, if I sort by the department column, so let's go to our drop down again, I have 2 choices. I can sort A to Z or Z to A. So if I sort A to Z, it's going to put the accounting department at the top. And if I sort Z to A, it's going to put the sales department at the top. Now, maybe I don't want my records sorted into either of these orders. Maybe I want to sort by marketing first, then finance, then HR, then IT, then accounting, so on and so forth. So I want a very specific order in which to sort my records. This is where we can use a custom list. So let's cancel out of here. And the first thing I'm going to do is I'm going to extract from column D a unique list of all the departments, because currently we have lots of repeats. So what we can do here is let's give ourselves some space over here. Now to do this, I'm going to use the unique function. And unique is brilliant because you can select a column or a range of cells and only extract the unique values from it. So I'm going to click in the first cell. Let's do Control Shift down arrow to select all the way down to the bottom, close the bracket, hit enter, and you can now see in column P, I have a unique list of all of those departments. So now I can actually see my unique departments. It makes it a little bit easier for me to just define the order that I want. So maybe I want finance first, then I want marketing, then we're going to have accounting. Let's go for sales next, then IT, engineering, and finally human resources. So this is the order that I want to sort this column by. So what we then need to do is create a custom list. And we do this by going to the File menu and all the way down to Options. This is a very well hidden little command. Now we need to go to the Advanced page, and if we scroll down towards the bottom, in the General section, we have this option here, Edit Custom Lists. So when we click on this, it's going to open up the custom list box. And what you'll see in here are custom lists that you already have available in Excel. Now, Excel has its own custom lists. You may be aware of these already. For example, when you type Sunday into a cell, you can then use the fill handle to drag down and fill in the rest of the days. The same with the months of the year. Those are custom lists. And you can see at the bottom here, I have a custom list that I've already created, and we're going to create another custom list for these departments. Now, when it comes to creating a custom list, you can select New List at the top here, and you could simply type in the entries. So I could say finance, marketing, so on and so forth. Alternatively, if you have them listed out in cells, you can simply click in this box down here, select the order, and then choose Import, and it's going to import all of those in. Let's click on OK, and OK again. So now we have that custom list set up, we can use it to sort the department column. So I'm going to click in the column. Let's go to the Data tab. We're going to open up Sort. We're going to sort by department. We're going to sort on the cell values, but when it comes to order, we're going to choose Custom List. It's going to open up that same window. We can then choose our sort order, click on OK, OK again, and you can see it's now organized those based on the custom list that I selected. And once you've done that, you can basically delete out everything that you put into this column, and it's not going to affect your custom list because we imported that information from the cells. So that's how you can sort using your own custom list. Have a play around with it. I think you'll like it. In the previous lessons, we've seen how we can perform a sort on multiple columns, and we've also seen how we can use a custom list to create our own sort order. But did you know that you can also use a formula to do a sort on a dataset? In the last couple of years, Microsoft have released two new formulas, sort and sort by, and these are dynamic array formulas that we can use to output our sort results anywhere in the worksheet. And that is one of the biggest advantages. If we were performing just a regular sort on this data, we could go up to the Data tab and choose one of our sort options. But your data is always going to be sorted over here in these columns. However, now, because we're going to be using a formula to do a sort, it means that we can place our sort results anywhere in the workbook. Another advantage of using a formula to do a sort is that we can combine it with other functions such as filter to really unlock the full potential of sorting and filtering. So let's first take a look at the sort function and see how it differs from the sort by function. Now, if we click in cell F5, let's type in equals sort. Now, the sort function has 4 arguments, but only the first one is mandatory. So we always need to select the array that we want to sort. Now, I'm going to be selecting everything in this data set, but just note that you don't have to. Your array could be these 2 columns, and you could just sort on those. So it really depends what it is that you want to sort. Now, I'm going to sort all of my data, so let's do Control-Shift down arrow, and let's close our bracket because that is the only mandatory argument. Now, when we hit enter, we're going to get our results, and notice what it's done here. Because we haven't really specified what we want the sort to do, we've just selected the array. By default, it's going to sort it A to Z by the first column. So for us, that column is the block, and you can see here we're sorted A to Z. Now, of course, you might not want this sort order. This is where we can define alternative sort options. Another thing to note is that both sort and sort by are what we call dynamic array functions, meaning that they have this spill behavior. So even though we've only typed a formula into one cell, the results have spilled out into the other cells. And you'll notice that when we click in some of these other cells further down, we can't actually edit the formula in any of these cells other than the cell that we originally typed the formula into. So if I click on cell F5, I can edit. If I click down here, I can't. So just be aware of that. That's an expected behavior of dynamic arrays. So we've got this set of results. Let's start to make some changes. I'm going to go back up to the formula, comma, sort index. Now, whenever you see index in an argument, it normally means that the formula is looking for an index number as an input. And an index number would be 1, 2, 3, 4. So it's asking me here, which column do you want to sort by? And remember, Excel numbers columns from left to right. So if I want to sort by the pass mark, that is column number 4, comma. I then get to choose if I want to sort in ascending or descending order. And I'm going to choose descending because I want to see the highest marks at the top going down to the lowest. And then comma, we get to choose if we want to sort by the column or sort by the row. Now I want to sort by row, so let's type in false, hit enter, and let's take a look at our result. So now I can see that yes, we are sorting by the 4th column, the pass mark column, in descending order. We go all the way from 100 down to the lowest mark of 25. Now, the first question I normally get when I show people this is, well, what if I want to sort on multiple columns? Well, you could do that very easily using the sort by function, which we're going to look at in a moment, but you can also do it using sort. So currently I'm sorting by the 4th column, but if I wanted to say sort by the pass mark and then by the exam, I could do that. So if we go back up to the formula and we want to click just here where we have our sort index argument. And what I'm going to do is I'm going to wrap this in curly braces. So let's open a curly brace. We still want to sort by column number 4, but then we want to sort by column number 3. And we're going to wrap that in a closing curly brace. So I'm defining sort by column 4, then sort by column 3. And then the next argument is the sort order. So again, we can wrap this in curly braces. So I'm going to open a curly brace. So currently we have -1. So column 4 is going to be sorted first in descending order. It's then going to sort by column 3, and we'll say we want to sort in ascending order for that column. Close the curly brace. So simply by adding those curly braces in, we can choose to sort by more than one column. So let's hit enter. And those results will update. The pass mark column sorted in descending order, and then it sorts by the exam column in ascending order. And of course, if you want to make any changes, you can just come up here and you can modify the formula. So let's change this to sort in descending order for the exam. So if you take a look at the order of the exam for the top 2 results at the moment, it goes French then history for the pass mark of 100. If we change this, we should find it switches round to history followed by French. And of course, we could carry on going. If we wanted to sort by another column, we can simply add that in by editing the information we have inside the curly braces. So that is how you can use the sort function to sort on one or more columns. Let's take a look at sort by, because it is very similar. It's just the way that we select our arrays is slightly different. So let's type in sort by, and you can see it says sorts a range or array based on the values in a corresponding range or array. So our first argument again is the array. So we're going to select everything, Control Shift down arrow, comma. Then we can choose which array we want to sort by. So maybe this time I want to sort by the exam. Now, when we're using sort by, we need to select the entire array, comma. Then we can define the sort order. So let's do ascending order, comma, and then we can choose the next column that we want to sort by. So maybe then I want to sort by the block, need to select the array, and we can define if we want to sort in ascending or descending order. So I'm going to add a 1 on the end there. And we can carry on going, selecting arrays and defining how we want to sort them. I'm going to leave it at that. Let's close the bracket, hit enter, and we should find everything updates. So we're sorting by the exam column first of all in ascending order. So that is A to Z, and then we're sorting by the block. So if we take a look at this block of English results just here, you should find that the first column, the block column, is in ascending order, which it is, A to Z. So that's the difference between sort and sort by. A lot of people find it a little bit easier to use sort by if they want to sort on multiple columns, because people forget that you can use these curly braces. But you can technically use either to perform a dynamic array sort on your data. In this lesson, we're going to explore the filter function. And much like sort and sort by that we've looked at previously, filter is a dynamic array function, meaning that it has that spill behavior. We type the formula into one cell and the results spill down to the other cells. Now, the reasons for using the filter formula as opposed to just putting some filters on the top of your columns are pretty much similar to the reasons why we use sort and sort by. For example, if I click in this table, let's just add our filter drop downs to the top. I can go in and I can click the drop down and I can choose to filter my list by whichever subject I like. So maybe I'm only interested in the results for French and history. I can select those and my list will be filtered. Now, the disadvantage of using this method is that your filtered results are always going to be in the same location. So they're always going to be in columns A to D in this example. I'm also very limited with what I can do from here. So once I've applied my filters, I have a few different things I can do. I can select different things, I can employ text filters, but apart from that, there isn't a great deal else I can do with this filter option. Whereas if we use the filter function, our results immediately become dynamic, meaning that if anything changes in the original data set, the filter is going to update. Using a formula means that we can combine it with other formulas to make it more powerful, and it also means that we can output our filter results to any cell in the workbook. So let's take a look at how filter works. Now, I've got a small data set again over here. This is the data set we've been using in a few lessons. In the middle, I have what I want to filter by, and then I want my output to be over here. Now, notice I've already added in the column headings because I want to return all of the columns. It's worth noting that when you're using the filter function, you don't necessarily have to return all of the information from all of the columns. If you are only interested in the student, the exam, and the mark, maybe you don't care which block they're located in, you would just use this as your filter array as opposed to everything. So let's type equals filter, open a bracket. Now we have 3 arguments here. The last one is optional. The first argument is array. So that's what I was just referring to. This is going to be the data that you actually want to filter. Now I want to filter everything, so I'm going to select the entire array. Control Shift down arrow, comma. We can then decide what we want to include. Now notice in the middle here I have a filter. So I want to filter this list so that I only see the results related to students who sat the English exam. So for this include argument, I want to include when the exam, Control Shift down arrow, we want to select that range, is equal to whatever we have in this cell, because I could change this to something else to get a different set of results. Now that's all we're going to do here. We're going to close the bracket, hit enter, and you can see that's exactly what I get. I'm now only seeing the results related to students that sat the English exam. Now take a look at the first result for student Adam, who's located in the North block. So here he is in the original source data. If I change his exam to, let's say, French, notice how our results automatically update. Let's hit enter. Adam disappears from our filtered list. And of course, because we're using a cell reference to define our filter, if I change this to something else, so let's go for maths and hit enter, everything is going to update. So it's nice and dynamic. And of course, you could put this in a data validation drop-down list so you don't have to keep typing in the exam each and every time. Let's move on to another more complicated example now, where we're using multiple criteria. So this time we have very similar data, but we have two filters that we want to use. So I want to filter for all students who sat the English exam who are located in the West block. So we have two pieces of criteria. How does filter deal with that? Well, again, we need to select our array that we want to filter, Control Shift down arrow, comma. Now we want to define what we want to include. Now, if you have more than one piece of criteria, you need to enclose each criteria within brackets. So I'm going to open a bracket and we're going to say include when the exam is equal to what we have in this cell. Close the bracket. That's our first piece of criteria. Now we need to add in an operator to let Excel know what we want to do. So are we doing an and? Are we doing an or? So if I want to filter this list, wherever the exam is equal to English and the block equals West, we need an asterisk separating our criteria. That means and. We can then open the next bracket and define our next piece of criteria. So this time we want to include when the block, Control Shift down arrow, is equal to whatever we have in cell F8. Close the bracket. Now if I had more pieces of criteria, I could carry on going. I could do an asterisk, I can open a bracket, and I can carry on. We're going to leave it like that. Let's press comma and take a look at this last optional argument. So this is what we want Excel to return if it can't find anything that matches in the data. So I'm just going to say no records. Close the bracket, hit enter, and you can see now we just have the results of the English exam for students located in the West block. And if this changes to, let's say, French, and let's change the block to East, you can see everything dynamically updates. And once again, you could put these on data validation drop-down lists to make it even easier. Now, it's worth noting that the AND logic isn't the only logic that we can use here. We can also use OR logic instead. So the asterisk implies and. If we were to change this to a plus, we're now using OR logic. So let's hit enter, and we get a much longer list of results, which is what I would expect. Because here we're saying filter for all the records where the exam is equal to French or the block is East. So everything you see in here, the exam will either be French or the block will equal East. Let's take a look at our final example. Now this is where we combine filter with another formula. I did briefly mention this when we were taking a look at sort. I said we'd be coming back to this so you can see how these work together. And that's exactly what we're going to do here. We're going to do a filter with a sort. So once again I have the same data set, but this time I have three pieces of criteria that I want to filter by. So let's do our filter first of all, and then we'll deal with the sort. The array that we want to filter, well, I want to filter everything, comma, what do I want to include? Well, our first piece of criteria, remember, needs to go in brackets, is we want to include when the exam is equal to what we have in here, cell F5. Close the bracket. We're going to do an and, so we need an asterisk in here, open a bracket. Our next piece of criteria is that we want the block to equal what we have in cell F8. Close that off, and another asterisk, open. We want to include when the mark, this time we want to include when it's greater than 50, or what we have in cell F11. Let's close off our final piece of criteria, and I'm going to say that if it can't find anything, we just want no records in the cell. Let's close off our filter and hit enter and check out the results that we get. Now, of course, we can easily check that this is correct by using our filters. So let's filter for English, West, and greater than 50. So I'm going to say we want to see all the results for English, all the results for the West block that are greater than 50, and that is all of these. And if you recall, that is exactly what we were getting in our filter results. Remember, if I was to change these to pluses, so I could put a plus in here, I could put a plus in here, when we press enter, we're going to get a much longer list because we're doing an OR. Now, whenever we have our results of our filter, we can then combine it with sort to sort our results. So all I would need to do here is I can use sort or sort by. If I go up to the beginning of filter and type in sort, the array is being generated by the filter formula. So we can just jump to the end, press comma, and then we can choose the columns that we want to sort by. So maybe I want to sort by the pass marks, that's column number 4. I want to sort in descending order, and I want to sort by row, so we want a false on the end. Close the bracket, hit enter, and that's exactly what I get, a nice filtered list. And everything is completely dynamic. So if we change this to French, for example, I'm going to get a different set of results. If I change this to South, we get a different set of results. And if I change this to, let's put that up to over 80, I get a different set of results. So everything dynamically updates. So hopefully you can see there how awesome the filter function is, particularly when combined with other functions. In this quick lesson, we're going to take a look at the unique function, because this is one of those functions that is so useful in many different scenarios. Now, what the unique function does is it allows us to select a range of cells and simply extract a unique list from that range. For example, if I want to grab a unique list of the sales reps, I can do that using the unique function. Because if we look in the sales rep column, you can see that we have sales rep names repeated over and over again. So we have quite a few Bens, we have a few Adams in here, some Debs, some Susies, so on and so forth. So if I just want to list out all of the sales reps, I can use unique to do that. And because unique is another one of those dynamic array functions that spills down the cells, it means we can combine it with other formulas to make it even more powerful. And we're going to take a look at a couple of options that we have. So let's start out by doing a basic extraction of a unique list. Let's type in equals unique. Press the tab key. The only mandatory argument that we have here is array. So if I want to extract a unique list of the sales reps, I just need to select the first one, Control Shift, down arrow, and I can close the bracket off, hit enter, and that's exactly what I get, a unique list of those sales reps. Remember, we can only edit the formula in this first cell. So what else could I do once I have this unique list? Well, I could combine it with sort to sort this list of sales reps. So let's jump up to the formula bar. Let's add sort on the front here. Our array is being generated by the unique formula, so we just need to click at the end and define how we want to do this sort. So our sort index, well, we're sorting by the sales rep column, which is column number 2. We don't actually need to define that because it's already defined with the unique function. Now, if you ever just want to skip over an argument, you can just press comma again to move on to the next one. I can now choose if I want to sort in ascending or descending order. So let's do ascending, and I want to sort by the row. So we want a false on the end here, close the bracket, hit enter, and that's exactly what we get. These are now sorted into ascending order. Now let's undo a step just to take us back to our plain unique. So what else could I do here? Well, I could combine it with one of the brand new dynamic array functions in Microsoft 365, drop. So maybe I'm only interested in the last 4 sales reps. I could click up in the formula bar and I could wrap this unique in a drop. And what drop allows us to do is just simply to drop rows or columns from our results. So our array is being generated by the unique formula. I can then choose which rows I want to drop. So if I'm just interested in the last 4, I'm going to choose to drop the first 2 rows. Let's close the bracket, hit enter, and that's exactly what I get. If I wanted to drop the last two, I would change this to a -2, and the formula is going to update. Let's go back to our unique formula. And the final thing I'm going to show you here is just how you can convert this. So instead of having the sales reps listed in individual cells running vertically, we have them listed in one cell separated by commas. This is where we can use the array to text formula. So if we type in array to text, once again, our array is being generated by the unique function, and the final argument is optional. We don't really need it in this case. We can just simply close off array to text, and when we hit enter, we get that same list, but in a different format. And of course, one of the most popular ways to use the unique function is to combine it with data validation. So if I wanted to create a data validation list where people can select the sales rep, so let's just put that up here from a list, I could use unique to extract these values, and then I can go to data validation. We can select list, and the source for our list is going to be our unique values just here. Now with dynamic array functions, another important point to note is that I don't necessarily need to select the entire list. I can just select the first one, press the pound or the hash symbol, and that will effectively select everything in the unique range. That's particularly useful if you have a very, very long list. And what we should find is that when we go up to our drop down, we have the sales reps available to select from the drop down menu. In this exercise, we're going to practice some of the skills that we've learnt in this section of the course. And this section was all about sorting and filtering data. So we have a small data set on the left-hand side here that lists out some countries, the regions, the revenue, and the profit generated. Now, the first thing I'd like you to do is I'd like you to create a unique list of all of the regions, and I'd like you to use this unique list to create a data validation drop-down list in cell F4. Once you've done that, I'd then like you to create a filter that filters results by the region selected in cell F4. And these need to be output into this table just here. Now, when you're building that formula, I'd like to make sure that you add a meaningful message if there are no records to return. And then finally, I'd like you to sort the results A to Z by country. Give that a go. If you'd like to see my solution to this exercise, then please download the exercise 5 solution file from the exercise files folder. That's it for now. I will see you in the next section. In this section of the course, we're going to be discussing a very important topic in Excel, and that is how we can find duplicates within our data. And when it comes to finding duplicates, there are numerous different methods that we can use. So in this first lesson, I'm just going to show you a couple of tricks that you can use to find duplicates using conditional formatting. So if we take a look at this first data set, you can see that we have two lists of names. And the first list are all of the people that attended webinar 1 and all of the people that attended webinar 2. So maybe this is some kind of training presentation that's been split across 2 webinars, and staff members are required to attend both webinars. So we've taken the attendance lists of both of these webinars, and now we want to compare the 2 lists to find out who didn't attend both of the webinars, because we need to send those people an email. Now, we can do this very simply using conditional formatting. So what we're going to do here is we're going to select the first row, Control-Shift down arrow to select both of the lists. On the Home tab, we're going to go to Conditional Formatting, highlight Cell Rules, and notice at the bottom here we have an option for duplicate values. So if we click on this, we get this little window pop up, and currently it's highlighting all of the duplicates with a light red fill and dark red text. Now, of course, you can click the drop down and you can change this to something else. So yellow fill, green fill, light red fill, or you can even choose your own custom format if you want to. So let's go with the green fill. Now, what I'm seeing here are all of the duplicate names. So when we have duplicate names, these people currently showing in green attended both of the webinars because they exist in both lists. So if I wanted to compose a big long list of everybody who attended, this would be a great way to do that. We can highlight those names. But what if I want to find out who didn't attend both of the webinars? Well, this is where we can click the drop down and we can choose unique. Now, when we click on OK, I can see who doesn't exist in both lists. So the names that we have underneath Webinar 1, these people are not in the Webinar 2 list, and the names highlighted in green in the Webinar 2 list don't exist in the Webinar 1 list. So now this makes it really easy for me to know who I need to send emails to. And if I want to get this formatting into more of a logical order, I can click at the top here and I could add some filters to the top of the columns. And then what we can do is click the drop down. We can say filter by color, filter by cell color, and choose the green. And it's only going to show me the people who didn't attend webinar 2. I would then need to go in and do the same for this list. So we can go to filter by color. We're going to select green. And we need to remember to clear this filter, and then we're going to see who didn't attend webinar 1. So that is the first method that you could use. Now we do have another method which is better when you're comparing rows. And this isn't necessarily conditional formatting, but I've decided to include it in this lesson anyway because it's really, really quick. So you can see here we have again two lists of data, serial number 1 and serial number 2. And what I want to do is I want to check to see if the value in the serial number 1 column is the same as the value in serial number 2. So we're effectively seeing if there are any row differences. So if we need to do that and compare things across rows, we can simply select our data set, press Ctrl G to jump into the Go To dialog box, and we want to go into Go To Special. Now we have an option in here called Row Differences. So when I select that and click on OK, you can see it's going to highlight in the table where there are differences in these rows. So it's highlighted the second one down. And when I say highlighted, it's actually not highlighting them, it's just selecting them. But it's telling me that this serial number in the second row is different to its counterpart in the first row, and the same for the bottom two. And I can see that yes, if we take a look at this second one, in the first column, it's 8890. In the second column, it's 8850. So maybe somebody's made a typo error just there. So that little option is perfect if you just want to find out if there are differences between rows. Have a little practice of these. They are super useful, and I will see you in the next lesson. In this quick lesson, I'm going to show you another method that you can use when it comes to finding duplicates across different lists. And this time we're going to be using formulas. Now, much like the last lesson, we have two lists of people who attended webinars. But this time I want to find out who did attend both webinars, because I want to send them a follow-up email. Now I know that we had some no-shows, so I just want to compare both of these lists together and just get a big long list of everybody who went to both webinar 1 and webinar 2. Now we can do this using the filter function, which is a reasonably new function in Excel, and COUNTIF. So let's click in cell D6. We're going to type in equals and we're going to type filter. So our array. Now for this example, we just want to select the first column as our array. Control Shift down arrow, and I'm going to press F4 to lock those cells, comma. And the second argument include, this is where we want to do our COUNTIF. So if we type in COUNTIF, our range is going to be all of the participants in the second list. F4 to lock, and our criteria is going to be everybody in the first list. Again, Control Shift down arrow and F4 to lock. So what we're doing here is we're basically counting the participants who attended webinar 2 against webinar 1, and then the filter allows us to extract the names as opposed to a count of the values. So let's close off our COUNTIF, close off our filtered, hit enter, and that gives us a list of all of the people who attended both webinars. So I can now safely send an email out to these people following up on the webinars. And this is going to give me a list of all of the people who attended both webinar 1 and webinar 2, so I know who to send my email to. So don't forget that aside from conditional formatting to find duplicates, aside from using that row differences option in Go To Special, we can also compare lists together using the filter and COUNTIF functions. Now we just did this on 2 columns. You could modify this and do it on more columns. So maybe you've got 3 columns, 4 columns, 5 columns that you want to compare together. It's time now to do exercise 6. And in this exercise, we're going to practice some of the skills that we've learnt in this section of the course. And in this section, we were taking a look at how we can find duplicates. So this is a fairly straightforward exercise. You can see in column B, we have a list of countries. And in column C, we have another list of countries. Now, what I'd like you to do is in column D, in the result column, I'd like you to add a formula that compares the country list in column B with the country list in column C. So I'd like you to find which countries appear in both lists. So think about the formula that you need in order to achieve this. And if you'd like to see my solution to this exercise, then download the exercise 6 solution file from the exercise files folder. Good luck with that, and I will see you in the next section. In this lesson, we're going to take a look at 3 very important statistical functions: mean, median, and mode. Now, these are very simple functions to use, but it's important to understand how they work and also the difference between them. So let's take a quick look at the data set. Now, what I have here is a list of results from the 5-kilometer park run that occurred at the weekend. You can see a list of all of the participants, their bib number, their age, and also the time that they achieved for 5 kilometers. And at the bottom here, I want to work out what the mean, median, and mode is for both the age and the time. Now, what is the difference between all 3 of these functions? Well, let's start with the top 2 first of all, mean and median. Now, mean is just another way of saying average. And if you're familiar with Excel functions, and you should be by now, you'll know that we have a function called average. And what an average does effectively is it adds up the list of numbers and then divides them by the count. So if we have 10, 10, 10, and we want to find the average function will add these together, which would give us 30, and then it would divide it by 3, which gives us 10. So the average would be 10. So that is the same as mean. So if you see mean anywhere, it's just looking for an average calculation. So we can do this very simply down here. We're just going to select average. We're going to select our numbers, close the bracket, hit enter, and then we can drag that formula across to get an average of the time. Now, the time looks a little bit different here, and that's just related to the formatting I have applied to the cell. So I want to open up my formatting, and I'm just going to make sure that I have the same formatting applied. And I think I have this one here. Yes, so hours, minutes, seconds. Let's click on OK. So I can see that the average age is 37.84. Now, in general, you wouldn't have it in that much of an increment, so I'm just going to take those decimal places down, which will round that up. The average age of participants in this 5-kilometer race is 38 years old. And the average time that they took to complete this race is 28 minutes, 16 seconds. So that is our mean. Now, what do we mean by median? Well, median is slightly different because median will just simply tell you what the middle value is from a range of cells. And a lot of the time, whilst it will normally be fairly similar to the average, it can differ very slightly. Now for this one, we have an actual function called median. So let's select it. You can see here it says returns the median or the number in the middle of a set of given numbers. So we just need to select our numbers. So again, we're going to select for the age, close the bracket, hit enter, and you can see the median, if we take those decimal places down, is 36. So the middle value is different to the average value of this range of cells. Let's copy this across. And again, it's giving me 0. That's just the formatting that I've got applied. This time, just to make things really nice and quick, I'm just going to copy the formatting using Format Painter. So let's click it once and let's apply it to this cell. And you can see again, there is a very slight difference here of 16 seconds. So that's the difference between your average or your mean and median. Now, mode is slightly different. What mode will tell you is which value is repeated most often in a range of cells. So if we type in equals and go to mode, notice that we have mode.mult and mode.sngl. Now, the difference between these two is that mode.mult will effectively return a vertical array of the most frequently occurring or repetitive values in an array or range of data. So it will effectively spill the results if there are more than one. Because it might be that you have, in this example, 3 people who are age 34 and 3 people who are age 40. So if both of those occur more than any other values in the list, we want to be able to list them out, and that is where we would use mode.mult. And I'll show you an example of that in a moment. For this one, we're just going to do mode.sngl. And this will just return the most frequently occurring or repetitive value in an array or range of data. So this is only going to show you one value. So let's double click it. Let's select our range, close the bracket, hit enter, and you can see here that the most frequently occurring age in this range is 35 years. Now if I just select this list, and I'm just going to go up to conditional formatting and say highlight cell rules that are equal to 35, just so we can see. So 35 occurs twice in this list. So we don't have any other numbers that occur 3 times, 4 times, twice is the maximum. But check out what we have in here. If we take a look down, you might notice that we have 2 people who are 48. We also have 2 people who are 50 in this list as well. So all of these occur twice, but because we've used mult.single and it can only output a single result, it's basically going to give you the first one that it finds. So it starts at the top of the list, it searches down, it gets to 35, that's the result that we're getting. Now let's copy this across. Once again, I'm going to copy the formatting to the cell using the format painter. And we can see here that the time 2005 is the one that occurs most frequently. And I can see, yes, there is a time of 2005 and there is another one. And because these are times, it's quite rare for people to get exactly the same time. So 2 is the highest amount of times this value occurs. So with all that said, let's just finish up by taking a look at that mode.mult. So we're going to go into mode and we're going to choose .mult this time. Once again, let's use the ages. I'm going to select this list, close the bracket, hit enter, and can you see we get a spill effect here? So this is listing out all of the ages that occur twice. So we have 35, 44, 48, 50, and 32. So that is the difference between mode.mult and mode single. But that's pretty much it. These are very straightforward formulas. Of course, we can combine them with other formulas to make them more powerful, but that's the premise of how they work. It's time now to explore 2 really important but often overlooked functions in Excel, and that is large and small. So what are large and small and how are they useful? Well, large can effectively extract from a data set the largest value, and small can extract the smallest value. So let's take a look at these in their most simplest form first. Notice that the table of data that we're using just lists out some artists, their albums, the genre they belong to, and the sales for each of those albums. So maybe I want to extract from this data set what the highest selling album was by sales. So what I could do, and I'm just going to do this down here first of all, is type in equals large, open the bracket. We have 2 arguments. We have array and then we have k value. So if I'm just looking for the highest amount of sales, my array is going to be the sales array, Control Shift down arrow, comma, and then I just need to provide the k value. Now I'm only looking for the top amount of sales in this list, so my k value is 1. If I wanted to find out what the second highest selling album was, I would have 2 in here. So let's stick with 1. Let's close the bracket, hit enter, and I can see that the top selling album achieved this much in sales. So let's apply some accounting formatting, take those decimal places down. So 4.5 million in sales. And we can see that that's true because I actually have this table of data sorted to have the highest sales at the top. So we can see here that Miss Taylor Swift is sitting pretty at the top of this list with her Reputation album that's achieved 4.5 million in sales. And small works in exactly the same way. We can type in equals small, and this time it's going to extract the lowest value. So again, we could select the sales column, Control-Shift down arrow, comma, and say we want the smallest, which is going to be the first position. So close the bracket, hit enter, and we can see that this is the album that achieved the lowest amount of sales in our data set. And if we jump down to the bottom, Control down arrow, we should find that this is it just here. So we have Ed Sheeran with his Divide album, 367,000. So that's how large and small work if you just want to extract one value from a list. That could be the first position, the second position, the third, so on and so forth. But what if we want to extract multiple? You can see here we have a small table that says top 5 sales. So maybe I want to find out what the top 5 sales values were in this column. This is where it's slightly more tricky. Because if we click in here and we're going to use large, our array, well, we're looking in the sales column, Control-Shift down arrow. And if you want to jump all the way back up to the top so you can see your formula, Control backspace will take you back there. We can press F4 to lock, comma. What's our K value going to be? Well, in the last example, we typed in a 1. So let's type in a 1 and see what happens. Close the bracket, hit enter. Well, it looks good for that first one, but if I drag this down, you can see it's just going to repeat those because in each and every formula, it's just looking for the same thing. It's looking for the highest value in this sales range. But what we actually want it to do is list out the highest, the second highest, the third highest, so on and so forth. So we need to go about this in a slightly different way. And a way that I like to do this is I like to have the values written out in cells. So you can see here I have 1, 2, 3, 4, 5. So when I drag this formula down, the relative referencing is going to update each time, which is going to produce a correct formula. So instead of typing in 1, 2, or 3, I'm going to select the cell G4. We're going to leave it as a relative reference, hit enter, and now when we drag this down, you can see that we get the correct results. And we should find that these match up with the top 5 albums in our dataset. And I can see that they do. Now, what about if I wanted to take this on a stage further, and instead of just extracting the top 5 sales values, which don't mean a great deal, maybe I want to see the actual album names that these relate to. Well, this is where we could wrap this in an XLOOKUP. So let's go up to the formula bar because it's a bit easier to see. I'm going to type in XLOOKUP. Now our lookup value, well, that's going to be generated by our large formula. So all we need to provide here is the lookup array and the return array. So our lookup array is going to be our sales again, Control-Shift down arrow, F4 to lock. What do we want to return? We want to return the album name, Control-Shift down arrow, F4 to lock. Let's close off our XLOOKUP, hit enter, and then we should find that when we copy this down, we get the top 5 albums, but we have the album name instead of the value. And once again, if I just highlight these in the table, you can see that those all match, so we know our answer is correct. So that's a couple of examples of how you can use the large function. And as you would imagine, small works in a very similar way, except we're not extracting the top 5 results, we're extracting the bottom 5 results. So let's just very quickly do this. I'm going to type in equals small. Array, well, again, let's go for the sales, Control-Shift down arrow, Control backspace to jump back up, F4 to lock, because we don't want these to move when we copy the formula down, and our K value is going to be what we have in cell G4. Close the bracket, hit enter, and then we can copy this formula down. And once again, if we go to the bottom of our data set, we should find that these match up. And I can see that they do. Now, what about if we want to use large and small in a slightly different way? So in these examples underneath, I want to extract the highest sales in the pop genre. So we're adding in a piece of criteria just here. Now, whenever we want to test a piece of criteria, we would use a logical function. So what I'm going to do is I'm going to combine the large function with if. So let's type in equals large, and we're going to go straight into an if, because our logical test is if the genre is equal to pop. So I'm going to select the genre column, Control Shift down arrow, F4 to lock. That needs to equal, and I'm just going to hard code this in because I don't have it written out in a cell. Now, if that's true, we want it to return the sales values, Control Shift down arrow, F4 to lock. We're going to close off our if, and then we're going to tell Excel what our K value is. So our K value again is just G13. Close the bracket, hit enter, double click to copy down. And once again, if we wanted to see the album names instead, we could wrap this in an XLOOKUP. So let's go back up to the formula bar. We're going to type in XLOOKUP. Our lookup value is everything that we have here. Our lookup array is the sales column, Control Shift down arrow, F4 to lock. But this time we want to return the album name. Control Shift down arrow, F4 to lock. Close the bracket, hit enter, and when we double click to copy down, we should find that this list is slightly different because this is just the highest sales in the pop genre. And if we take a look, we can see that Reputation is at the top there. That's in the pop genre. The next one down, again, is Taylor Swift, the Lover album. That's also in the pop genre. The next one down in the pop genre is this, so on and so forth. So let's finish off the full set. This time we're looking for the lowest sales in the hip hop genre. So we want to do a small. We're going to go straight into our if. Our logical test is if the genre, Control Shift down arrow, F4 to lock, is equal to hip hop. If that's true, we want to return the sales values, Control Shift down arrow, F4 to lock, close off our if, and then we can simply provide the K value. So that's cell G13, close the bracket, hit enter, and then we can pull this formula down. So a few different examples there of how you can use large and small in combination with other formulas to extract the highest or the lowest values from a list. In this lesson, we're going to take a look at two functions, rank EQ and rank average. And both of these functions are used to rank data. Now, if you take a look at my data set just here, you can see that I have a list of movies, and then I can see the number of 5-star reviews that each of these movies have achieved. And what I want to do in column C is I want to find out how these movies are ranked against each other. So what do we mean by ranked? Well, based on the number of 5-star reviews, I want to be able to see in column C if this movie is ranked number 1, number 2, number 3, number 4, number 5, so on and so forth. Now you might be thinking to yourself, well, can't we just do a sort? I could click in this column, I could sort these into descending order, and that would give me the top ranked by number of 5-star reviews at the top, going all the way down to the lowest ranked movie. Now, the problem with sorting is that it will rearrange the order of the movies depending on where they fall in the ranking. So let's just do that. Let's click in the reviews column. We're going to go to data and I'm going to say Z to A. So that's going to give me the top ranked movie based on 5-star, based on the number of 5-star reviews. But notice that the list of movies has now rearranged itself. It's reordered itself. Now, that might be totally fine. It really depends on what you're doing. But if you wanted to keep this list of movies in exactly the same position, but you still want to see how these movies are ranked against each other, that is where you would use the rank function. So what we're going to do here is we're going to type in equals rank. Now, notice something interesting here. We have rank average, we have rank EQ, and then we have rank. Now notice with rank, it has that little yellow warning triangle next to it. And whenever you see a function in this functions list which has this little yellow warning triangle, that means that it's a legacy function. So a number of years ago, all we had was the rank function in Excel. But since then, Microsoft have released updates. They've released 2 new ranking functions, rank EQ and rank average. So because these 2 functions achieve exactly the same thing as the older rank function, this is now what we refer to as a legacy function, meaning that it is kind of still available in Excel, so any older workbooks that use this function will still work and calculate correctly, but it's just a warning that we have newer functions to be able to do the same thing. And the newer function for rank is rank.eq. So let's double click it. Now we have 3 arguments for rank.eq: number, reference, and the final optional argument of order. So the first argument is number. Now this is the number that you want to rank against everything else in the list. So I'm going to select cell B4, comma. We want to rank this against everything else. So Control Shift down arrow to select everything in that column, Control backspace to jump back up to the formula. Now I don't want this list to move when we copy this down, so I'm going to press the F4 key to lock those cell references in place. Now let's just close this off, hit enter, and then when we double click to copy this down, it's going to assign a number next to each movie, and this is its ranking. So the first movie here, 12 Angry Men, this is ranked 12 based on 5-star reviews. If I scroll down a bit, there is the number 1 ranked movie, The Departed. So this one has the most amount of 5-star reviews. And of course, if you wanted to check that, you could apply a sort. I'm going to say smallest to largest, and you can see Departed is there at the top. Let's undo to take this back. Now the final argument of rank.eq, which we didn't complete, was order. Now if we press comma, you can see we get 2 options. We can choose to rank in descending or ascending order. Now if you don't specify anything here, it's going to do the default, which is descending. So if we add a 1 on the end here, it's going to rank them the other way around. So let's hit enter and let's double click to copy down. And now I can see that 12 Angry Men is ranked effectively 39th from the bottom. If we go down and find number 1, that's this one just here, this is basically the lowest ranked movie based on 5-star reviews. So that is how the rank EQ function works. Pretty straightforward. And the cool thing about this is that everything's dynamic. So if I was to change this to, let's go for 5,000, it will readjust its ranking order. Let's take a look at another example now where we're going to use rank average. So here we have a list of dates and we have the amount of calls logged on those dates. So maybe this is some data that's come from a call center. Now the first thing we're going to do is we're going to complete a rank. So the same as what we did in the previous example. So let's type in rank.eq. The number we're trying to rank is this number just here, and we're ranking it against everything in this list. Control Shift down arrow, F4 to lock. I'm going to take the default of descending order. Let's close the bracket, hit enter, and then we can double clickety-click to copy down. So I can see here that the day where we had the most amount of calls was January the 4th, 2023. Now let's do the same thing, but this time we're going to use rank average. We have exactly the same arguments. So we're going to choose calls logged. Our reference is what we're ranking it against. Control Shift down arrow, F4 to lock, comma, and I'm just going to do descending order again. So we don't need anything on the end there because it is the default. Let's hit enter and let's double click to copy down. Now you'll see that some of these are exactly the same. The rank average and the rank for the first one are the same. But take a look at the second one. The rank average is 16.5, whereas the rank is 16. And again here, the rank average is 1.5 and the rank is 1. So why do we have a difference here? Well, to make this a bit easier to see, let's just sort the rank average column. So now we can see a direct comparison. Now check out both the rank and the rank average columns. You can see with rank, we have 2 number 1s. And that is because the amount of calls logged on these 2 days were exactly the same. They took 197 calls on both of these days. So this is the highest value, so both are ranked in position 1. Notice that the next highest number of calls is ranked in position 3. So if you have two that are the same, it will essentially skip over number 2 and go straight on to number 3. And we have a similar thing down here. We have 2 days where we took 144 calls, so the rank is 16. 17 is skipped over, and the next one is position 18. So that makes sense. But why is the rank average different? Well, with a rank average, what it basically does is it adds together both of these rank positions. So this first one is position 1, the second one is position 2. So if you add those together, we get 3, and then if we're doing an average, we divide 3 by the 2 positions, which gives us 1.5. The same thing down here, where we have 16.5. This one is in the 16th position. This one is effectively in the 17th position. If you add both of these together, you get 33. Divide them by 2, you get 16.5. So that is the difference between rank and rank average. In this lesson, we're going to talk about the subtotal and aggregate functions. And I've got a few different examples to show you here, which will hopefully explain why these are useful. So let's start out with the subtotal function. Now, the first thing to point out here is that the subtotal function is different to the subtotal utility that you can find on the Data tab over in the Outline group. Notice we have a subtotal command just here. Currently it's grayed out because I'm not clicked in a data set where I could apply this, but this will allow you to quickly calculate rows of related data by inserting subtotals and totals. So this is more of your traditional subtotal. It will create an outline of your data, and then wherever there is a change in a column, it will apply a subtotal. And we'll look at that a bit later on in this course. In this lesson, we're going to talk about the subtotal function, which works in a different way. So in this first table just here, you can see that I have a list of employee names, the department they work in, and their salary. Now, maybe I simply want to sum everybody's salary. Well, we could use the sum function to do that. So if I go up to cell B3, type in equals sum, I can then simply select this column, and it is worth noting that I formatted each of these as a table, so I can simply click to select the column, close the bracket, hit enter, and it's going to give me the total of all of the salaries. Now I can do a very similar thing with subtotal. So let's type in equals and jump into subtotal. Now the first argument of subtotal is function name. Now notice we can do a lot more things with the subtotal function. We're not just restricted to doing a sum. We could do an average, a count, a count A, a max, a min, so on and so forth. And notice that option number 9 in this list is sum. Now something that you will notice is if we scroll down, these start to repeat. So number 1 is average, but as soon as we get to 101, that goes back to average, and then we have all of those functions listed out again. Now I'll explain in a moment what the difference is between this first set 1 to 11 and the second set 101 to 111 in a moment. For the time being, we're simply going to do exactly the same as what we did before, and that is a sum calculation. So I'm going to select sum from this list, comma, reference 1. We then just need to choose the cell range that we want to add up. Now I want to add up the salary column, so I'm going to select it again, close the bracket, hit enter, and of course we should find that we have exactly the same. Like so. So you might be thinking, okay, well, that's great. What's the advantage of using subtotal over sum? Because sum is so much quicker. Well, check out what happens if I was to filter this list of data. So I'm going to go to the department drop down, and let's say I only want to see employees who are in the HR team. I'm going to select HR, click on OK. Notice what happens here. So the sum is still showing as 880,000, whereas the subtotal is showing as 151,000. So you can probably see the difference straight away. Sum will include even filtered out cells in its total, whereas subtotal will just show you the totals for the cells that are visible. And that can be really useful to know. There are so many different scenarios where you might have different filters applied, and you're wondering why the total is including all of that excluded data. This is why you need to be using SUBTOTAL. Now let's put all of our departments back again. I'm going to select all and click on OK. Because if we double click to take a look at this SUBTOTAL function again and go back to the function number, I'm just going to delete out what we have in there. It's fairly straightforward to understand that we have other calculations we could perform. So instead of sum, I could have done a count, I could have done an average of all of the salaries. So you can choose whichever function you like. Now, what I want to demonstrate just here is the difference between this first set of 11 functions and the last set of 11, because as I mentioned, they do repeat. So this time I'm going to choose the second sum in the list, which is function number 109. Let's double click. Let's hit enter. As we would expect, we're getting the same as our sum calculation. Let's see what happens if we apply a filter. So I'm going to apply the same one. Let's select HR and click on OK. And it's working exactly the same as the previous sum that we did. So why would we select the second sum from that functions list as opposed to the first? Well, let's go back and select all of our data. Maybe instead of filtering, I've manually hidden some rows in this table. So I'm going to select rows 10 to 13. I'm going to right click and I'm going to hide. Check out what happens. The subtotal updates and it excludes the manually hidden rows. Now, if I'd have used the first sum in this list, number 9, let's select that and do that one instead. Check out what happens. The first sum will include any manually hidden rows. So that is the difference between those two different sums in that functions dropdown. Something that you really need to be aware of. So now that we understand subtotal, let's move on to talking about aggregate. Because aggregate works in a similar way, but it allows us to deal with things like errors in cells. So once again, we have a very similar data set. I do have an additional column just here though, which is telling me the bonus amount for each employee. And if I click on this first cell, you can see that I've calculated that by simply multiplying the salary column by the value that we have in cell H1, which is 20%. This is the bonus amount effectively. Now notice in this bonus column, I have a few errors. I've got these div errors in here, indicated with this green triangle. Now, how does this affect any calculations I'm performing on this bonus column? Well, let's take a look. I'm going to type in equals sum, and let's just select this bonus column. Close the bracket, hit enter, it's going to give me a div error. So if you have div errors in cells and then you're trying to do things like add up that range of cells, you're going to get a div error as well. It can't calculate it. So what about if we go underneath and use aggregate instead? Once again, much like the subtotal function, we get a list of different functions that we could use. So I want to sum, so let's select number 9, comma, I get a whole bunch of options with this formula. So I can do things like choose to ignore any hidden rows. I can ignore error values. I can ignore nothing. So what I could do here is I could say, okay, I want you to ignore the error values. I'm going to select that one, comma. We then just need to select the array. So I'm going to move this screen tip out the way so we can get to the bonus column. And that's all I need here. The final argument is optional. Let's hit enter and you can see it gives me my result. So it's basically ignoring the errors that I have in this column. And with the aggregate function and that options argument, this would also work if I had manually hidden rows. So if we come out of here and let's apply a filter again. So I'm going to filter by department. Let's just see everybody in marketing. Click on OK. I can see that this total is incorrect because I know that the sum of these two numbers does not equal 153,000. But if we double click to modify this formula, we can change the option that we're using and say ignore hidden rows and error values. So let's use this one instead. Hit enter, and now that total is correct. So it really makes a big difference which one of those options you're using when you're working with aggregate. Now, the final example that I just want to finish off with is a way that you can effectively sum and count values based on the background fill of the cell. And this is a question that comes up often. Unfortunately, in Excel, we don't have a specific function in order to do this. And it would be amazing because I know so many people who have to do this and really struggle. So you can see here that I have some conditional formatting applied to this dataset. And my conditional formatting rule that I have just here is basically saying format all of the rows where the salary is greater than 50,000. And that is the result that we get here. So maybe I want to add up all of the salaries, but only for the people highlighted in the table. So how would I do this? How can I sum or count by the background fill color of a cell? Well, we have to think outside the box a little bit just here. We can do it using subtotal or aggregate. So let's do the sum first of all. I'm going to click in the box above. Let's do subtotal. I want to do a sum this time, so let's select that from the list, comma. What am I adding up? Well, I want to sum the salary, and that is it. Let's close the bracket, hit enter. Now it's giving me 880,000. So this currently isn't the correct answer. But what we could then do is apply filters to this table in order to get the correct result. So I can go to any of these columns because we have the formatting applied across all of the columns. And I could say filter by color, and then I can choose the background fill. That's going to filter the list so we only see the formatted cells. And the total this time is correct. And if you want to check that, you can select these cells, take a look down in the status bar, and you can see it says 291,000. So that is a nice way that you can get around that. Now we could do something similar using aggregate. So let's finish off by doing that. And this time we're going to do a count. So let's double click to select count, comma. We get our options up here again. So I'm going to say ignore hidden rows, comma. We need to select our array. So I'm going to select the salary column, close the bracket, hit enter. Now the count currently is 21 and we have 21 people in our list. But if we apply the same filter, so let's go to filter by color and we're going to filter by this background green, you can see everything updates and the count is now showing as 5 because we chose to ignore hidden rows in the formula. So that's how subtotal and aggregate work, and a few examples of why these functions are so useful. It's time now to complete exercise 7. And in this exercise, we're going to practice some of the skills that we've learnt in this section of the course. And in this section, we were looking at statistical functions. Now, I have a table on the left-hand side that lists out some players. And in column C, we have the score that they achieved in a video game. So the first thing I'd like you to do is to calculate the average score, the median score, and I'd also like you to calculate which scores appear most often in the list. Once you've done that, I'd like you to move on to the second part of this exercise, and that is to rank these players in ascending order according to their score. See how you get on with that? If you'd like to see my solution, then don't forget to download the exercise 7 solution file from the exercise files folder. That's it for now. I will see you in the next section. In this section of the course, we're going to talk about rounding values. And when it comes to rounding, there are 3 main functions that you can use: round, round up, or round down. Now, there are other rounding options which we're going to explore in the next lesson, but in this lesson, we're just going to focus on those 3. And rounding is a really important thing to know, particularly if you work in the financial sector, where it's extremely important that we are accurate when it comes to money. So let's take a look at our first example. Now over here you can see I have a small table. We have some order IDs, so these are orders that have been placed by customers. We have the price of the order, and then we have the price plus tax. And if we click in the first cell just here, you can see that we have a calculation which is working out what that price is plus the tax rate. And we can see over in cell F4 what that tax rate is. So there is a 2.50% tax applied to all orders. Now, the calculation to work this out is fairly straightforward. You can see it up there in the formula bar. We're just doing cell B4, which is the price, multiplied by the sales tax. This is an absolute reference because when we drag this formula down, we don't want this sales tax cell to move. And then we're adding B4 on the end. Now, if you're wondering why we're doing that, if I was to remove the plus B4, all we're going to get in the cell is the tax amount. So 2.5% of $4.88. If we want the price plus the tax, then we need to make sure that we're adding that price back on the end to get the total. Now, currently with these numbers that we have in column C, if we go to the Home tab and take a look at the formatting we have applied, we have number formatting. And this is a really important point to note when you're working with formatting. The number formatting is simply a mask that sits over the actual number. So a lot of the time, the number that you see in the cell isn't necessarily what the underlying number exactly is, because we've applied formatting over the top to make that number look a certain way. And that's the same with all of these formats that you might choose to apply. So with that in mind, let's do something else so you can see why rounding is so important. So let's say that this first customer with the order ID 1000 wants to order 1,000 products. And we know that the price per product is $4.88. So how would we calculate that? Well, we're going to include the tax. So let's do equals price plus tax multiplied by 1,000. Now, before I even hit enter here, this is a fairly straightforward calculation that you can probably do in your head. So what you're going to be expecting the result to be is 5,000. Let's hit enter and see what we get. We get 5002. So why is this value not 5,000? Well, this is related to rounding. So if we go back to this first cell where you can see 5.00, let's see what happens when I reveal more of this number, because currently I'm only showing this value with 2 decimal places. So if we go up to the Home tab and into the number group, we have these little increase and decrease decimal buttons just here. So let's increase the decimals to reveal more numbers. Check out what happens when I click it once. The next number is 2. And that's exactly the same as what I'm getting in cell E5. And I could carry on increasing those decimals to see more of the actual number underneath. So the actual value is 5002, but because we're only choosing to show 2 decimal places just here, it's effectively rounding it down. So how can we get both of these values to look the same? Well, this is where we could use rounding. So I'm going to go up to the formula in the first cell. We're going to type in round, and notice the different round functions we have there. We have round down, round up, and M round. So let's press tab. The number is being generated by the formula, and all we need to do is tell Excel how many digits we want to round to. So if I was to type a 2 in here, let's close the bracket and hit enter. So now both of these values look the same because we're rounding to the nearest cent. And of course, we could use round up or round down. So let's go to round up. I'm going to keep it on 2. And you can see there it says rounds a number up away from 0. If we hit enter, you can see it's rounding it to the nearest cent. If I was to switch out this 2 for a 0, it's going to round it up to the nearest dollar. And now it changes to 6. And we could do the same with round down. So let's replace up with down. And you can see here it says rounds a number down towards 0. So this final argument really depends on the number of digits that you want to round to. So if I put 0 in here, it's going to round it down to the nearest dollar value again, which is $5. And with this first one selected, if we increase the decimals again, you can see now we just get a whole bunch of zeros. So just be aware of that, particularly if you work in finance. It's really important to apply rounding to your numbers to make sure that they're exactly correct. Now, just before we leave this lesson, I want to show you another example. You can see here we have some salaries. These might be staff salaries, and then we have their new salary after a bonus amount of 2.15% has been applied. And I've already added this formula in. If you take a look at it in the formula bar, you can see we have a round up in play here. Now, why have I done that? Well, if you take a look at the salaries, these are a little bit all over the place. They're not whole numbers. So we have 26,399, 23,379. They're not particularly neat and tidy. In general, if you have a salary, it's very rarely 26,399. It's more likely to be 26,000. So with the new salary, once we've performed this calculation, the bonus increase, notice that these are all nice and tidy. They're rounded to a whole number. So we have 27,000, 23,900. They're rounded to the nearest 100. And I managed to achieve this by doing a round up in the cell. So you can see here we're doing a round up, A29 multiplied by D28. So we're just multiplying the salary by the bonus amount. We're adding the salary back on, but notice I have a -2 in here. Now, what would this have looked like if I have a positive number in here? So if I put 2 in here, you can see the salary is kind of messy again. If I do a -2, it's going to take it to 27,000. So just be aware of rounding when it comes to dealing with figures, particularly if you work in the financial sector. In the previous lesson, we saw how we can use round, round up, and round down to round values in cells. And in this lesson, we're going to continue on in the same vein, but we're going to take a look at some more specialized rounding, specifically 3 functions called mRound, ceiling, and floor. So let's start with mRound. Now, the difference between mRound and the functions that we looked at in the last lesson is that mRound allows us to specify the multiple. So let's take a look at a couple of examples. Now, once again, I have a similar data set. We have order IDs, we have the price, and we have the price plus tax. And that has been calculated by multiplying the price by the sales tax value of 2.5% and then adding the price on again. So pretty much what we did in the last lesson. Now, if we go up here to the formula bar and we type in mRound at the beginning, notice we have 2 arguments. We have number and we have multiple. Now the number is being generated by our calculation, so all we need to do is provide the multiple that we want to round to. So here we can be very specific. So if I wanted to round all of these numbers to the nearest 50 cents, I could type in 0.5. Alternatively, you could just put 0.50. It's going to do the same thing. So now if we close the bracket and hit enter, we can double click to copy this formula down, and you can see that all of these values have been rounded to the nearest 50 cents. Now it doesn't necessarily always do a round up or always do a round down, it's going to be the nearest. So you can see here with the first one, the nearest 50 cents is $5, whereas this one, the nearest 50 cents is $6.50. So this one is rounding up, whilst this one is rounding down. What about if I wanted to round these to the nearest 20 cents? Well, I could just change this to 0.2, hit enter, and then double click to copy that down. Now, if you're looking at this and thinking, well, that's not the nearest 20 cents, because if we look at this one, the price is $7.19, but it's rounding up to $7.40. And looking at this, $7.19, because we're rounding to the nearest 20 cents, I would expect the result here to be $7.20. But remember, what you're seeing in this cell is a value with 2 decimal places. If I was to expand these decimal places out and take a look at this in the formula bar, you can see it's actually 7.192, so it's nearer 7.2. So it's going to round to the nearest 20, which in this case is to round up to 7.40. And if I wanted to round these values to the nearest dollar, I would simply replace 0.2 with 1. Hit enter, and then we can double click to copy that down, and everything is rounded to the nearest dollar. The same thing would work with different salaries. So let's say we have some salaries here and we just want to make these look a little bit neater and round them. And this time I'm going to round them to the nearest $100. So all I would need to do here is equals mRound. The number is this number just here, and we want to round to the nearest 100. Close the bracket, hit enter, and then we can simply double click to copy down and apply comma formatting and take those decimal places down. So these now look a lot neater than these salaries over here. So that's how the mRound function works. Now the other two functions, ceiling and floor, are basically the same as mRound, except ceiling will always round up, whereas floor will always round down. Remember, mRound will just round to the nearest. Now the arguments are pretty much exactly the same, so if we switch out mRound for ceiling and leave this on 1, you can see that we get a choice of two options. We have ceiling and ceiling.math. So ceiling is one of those legacy functions. Notice that it has that little warning triangle next to it, meaning that this used to be the only function that we had, but it's now been replaced with ceiling.math. So let's select ceiling.math. I'm going to leave it rounding to 1. Let's hit enter, double click to copy down. Now again, you might be thinking, well, hang on a second, why is this rounding to 6 when the price is $4.88? Surely this should round up to 5. But if we take the decimal places down in this case, you can see that the actual value there is 5. So it's going to round up to 6. The same with this one just here, $7.98. You might expect that to round up to 8, but if we take the decimal places down, you can see that the actual value is 8, so it's going to round up to the next multiple of 100, which is 9. And as you might expect, floor works in a similar way, except it's rounding down. So let's type in floor. Again, floor is a legacy function, so we want floor.math. This time let's round down to the nearest 50 cents. So I'm going to type in 0.5, hit enter, double click to copy down, and there we get our results. So that's the difference between mRound, ceiling and floor, and how those compare to round, round up and round down. It's time now to do exercise 8. And in this exercise, we're going to practice rounding values. Now, here you can see I have a table with a list of employee names, and it also shows their salary. Now, these employees are going to get a bonus of 1.2%. So the first thing I'd like you to do is in column D, I'd like you to calculate the bonus amount. So the bonus is going to be 1.2% of the current salary. Then in column E, I'd like you to calculate the new salary, including the bonus. And I'd like you to ensure that the result here, the total salary, is rounded to the nearest 100 multiple. If you'd like to see my solution to this exercise, then download the exercise 8 solution file from the exercise files folder. I really hope you get on okay with this, and I will see you in the next section. A concept that's really important to grasp as you get more and more advanced skills in Excel is custom formatting. Custom formatting allows us to really define how we want numbers and text to look in our worksheet. So in this first lesson, I'm going to talk through custom formatting so you understand what you're looking at, and then you can start building your own really cool custom formats. So in this first lesson, we're just going to talk through custom formatting so you understand what it is, because in my experience, this is something that people tend to struggle with. But it's actually pretty easy once you break it down. Now, notice here that we have a very small table. We've got a list of sales agents. We have the sales that they've generated and the commission that they've achieved. Now, currently, these numbers kind of look a little bit untidy, and that is because if we go to the Home tab and take a look in the number formatting group, you can see I just have general formatting applied. And general formatting isn't really any specific formatting at all. Now, ordinarily, what most people would do here is they would select the sales values, they'd go up to the drop down, and then they'd probably choose, because these are sales, currency, or accounting format, to make those look a little bit neater. Maybe we'd take the decimal places down. And we'd probably do something similar for the commission. Now, I'm just going to undo just to take those numbers back to how they were originally, because aside from these preset number formats that are built into Excel, if we go into more number formats, we have a custom group at the bottom. And this is where we can get really detailed about how we want our numbers to look. And what I find is that most people come into here and they start to scroll through this big list and they see all these hash symbols and all these dollar symbols, and it all looks quite complicated. So they generally tend to just cancel out of here and just use one of the presets. So let's take a little bit of time just to fully understand what we're looking at, because then it's just going to be a lot easier for you to create your own custom formats. Now, the first thing you need to understand about custom formatting, and if we go down to, let's just select this one here so you can see it in this type area. Custom formatting is divided into 4 parts, and each part specifies the format for a particular type of cell input, and each part is separated by a semicolon. So if you take a look at this just here, there's the semicolon. So everything before the semicolon, the first part, this defines how we want positive values to look in our spreadsheet. The next part after the semicolon, that defines how we want negative values to look in our spreadsheet. Now this one only has 2 parts, so we're only defining positive and negative values. But if we scroll down a bit further, you can see we have some in here that contain all 4 parts. So with this one, this is the number formatting that controls what positive values look like. This is the number formatting that controls what negative values look like. And then we have another semicolon and a third part in here. So this controls what 0 values look like in our spreadsheet, and the final part controls what text looks like. So we can effectively use different formatting for different types of input into our cells. So maybe I want the positive values in a selected range to show with a dollar symbol and 2 decimal places, but I want the negative values to show with no decimal places and to show in a red font. We could do all of this with custom formatting. And then maybe I want the 0 values to show as a blank instead of a 0, and maybe I want the text to look a specific way. This is what you can use custom formatting for. So it's really important to understand that this is divided down into 4 parts. Now you don't necessarily have to use all 4 parts, it really depends on the data that you're using. Now another thing that tends to throw people off are these hash symbols and zeros. Now these are placeholders. And if you take a look, I've selected this one just here. In the sample above, you can see what the number is going to look like if I was to use this custom format. So if you compare this number to what we actually have in the selected cell, you can see that this formatting is basically going to add a comma separator into there. In the worksheet, we don't have a comma separator currently. And the hash symbols and the 0 are effectively placeholders for numbers. The only difference between these two is that the hash symbol is a variable placeholder, whereas the 0 is a fixed placeholder. So something really simple I could do here is if I wanted to have this formatting here with the comma separator, but I also wanted a dollar symbol on the front there, I could simply come down to my custom format and add a dollar symbol. And you can see the sample updates. When I click on OK, it's going to apply that formatting to the cell. Let's undo. So this time I'm going to select the sales column. Let's go into custom, and I'm going to choose a custom format. So if I scroll all the way down, I want this one just here. So this is going to put a dollar symbol on the front and a comma separator. Let's click on OK to apply that custom format. Now, what about this just here? Again, I have some numbers, but I also have some 0 values in here. So let's go to custom formatting. This time I'm going to press Ctrl+1 keyboard shortcut to jump there quickly. Let's go to custom. And this time I want to have my numbers formatted in the same way, my positive values I should say. So I want them like that. But because I have 0 values in here, I want to apply a formatting for those. So remember, we need to press semicolon. That's going to move us on to the next position, which is how we want negative values to be formatted. Now, I don't have any negative values in my selected cell range, so I can press semicolon again, which will move me on to the next part, which is how I want zeros to be formatted. So maybe instead of a 0, I want it to say no commission. I could type into quote marks, no commission, click on OK, and let's widen this column out. And there you go. You can see that wherever we have a 0, we now have text instead. What about this example below? This is going to help illustrate to you the difference between those hash symbols and zeros. You can see here I have some order numbers in column 1, but these order numbers are very inconsistent in their length. So we've got order number 100, 5, 2000, 560, so on and so forth. But maybe I want all of these to be the same length. Maybe they need to be 5 characters long. Now, if I wanted to change the first one here to 5 characters, it would make sense to put a 00 on the front because the number is still effectively going to be 100. But if I was to double click here and try and add 2 zeros, Excel doesn't really like leading zeros. So what I could do is select this cell range, Control 1, go to Custom, and because these are all positive values, what I could do here is I could say that I want 5 fixed spaces, for example. So I would need to use zeros because zeros represent fixed placeholders. 1, 2, 3, 4, 5. You can see in the sample above, I'm now getting exactly what I want. So if I click on OK, the 0 being fixed will force everything to be exactly the same length. Now, if I was to do the same thing but use hash symbols instead, notice the difference. So let's type in 1, 2, 3, 4, 5, click on OK. It just takes us back to how it was before because these are variable, they can change. So that is the main difference between fixed and variable placeholders. And just to finish off this lesson, because we do have another lesson coming up where you can see custom formatting in action, let's take a look at this sales column just here because we have some minus values. So let's press Control 1. Let's jump into Custom. So in here, I want to format positive and negative values. So as we know, positive values are in the first position. Maybe I want the 500 to display, let's choose this one, with 2 decimal places after it. And let's add a dollar symbol at the front here. And now I want to define how I want my negative numbers to look. Now I basically want them to look exactly the same, but I want them to show in red. So I can copy this formatting, Control C, and just paste it in. And all I need to add on the front here is in brackets, we can add the color that we want to use. So I'm going to add in red. And those are square brackets, not curly brackets. Let's click on OK, and you can see everything updates and we have the result that we were expecting. So those are the basics of how custom formatting works. In the next lesson, we're going to explore this a little bit further and we're going to take a look at a really nice example. So I'll see you over there. In the previous lesson, we started to take a look at how we can use custom formatting to change the format of positive, negative, 0 values and text. So we're going to move that idea along in this lesson by taking a look at a more practical use of custom formatting. And we're going to incorporate color and symbols into our custom formatting this time. So let's start out by taking a look at the data set that we're going to be using. So we simply have a list of products. We have the actual quantity that was sold of each of those products, and then we have the target. Now, what we're aiming to do here is in column E, we want to work out the variance, i.e. the difference between the actual and the target. And then depending on what number we get in this column, we then want to apply custom formatting so we can see a visual representation via color coding and a symbol as to whether the actual was greater than or less than the target. So before we get too far ahead of ourselves, let's first work out what the variance is for each of these products. And this is a very straightforward calculation. We want to type in equals, and then we're going to do the actual minus the target. Now, if you ever struggle to remember which way round this goes, just remember that A comes before T in the alphabet. I'm going to do Control Enter, which is another shortcut I really like because if you were to just press Enter, it's going to move your cursor down to the cell below. Now, we want to copy this down, so it's going to be a little bit quicker for us to stay in the same cell. So that is why I use Control Enter. We can then simply double clickety-click the autofill handle to copy that formula down. Now you can see that in this variance column, we have a mixture of positive and negative values. And what you'll also notice is that for the electric toothbrush, we just have a 0 in here because the actual is exactly the same as the target. Now I want to represent these numbers in a more visual way so that it's instantly easy to see if we're below target or above target. So I'm going to do this using custom formatting. So with this range selected, I'm going to press Ctrl 1 to bring up the Format Cells dialog box, and we're going to go straight down into Custom. Now, if you recall, when we were looking at this in the last lesson, I'm just going to select one of these random custom formats. Our custom formatting is split into parts, and each part is separated by a semicolon. So everything before the first semicolon is how we're formatting positive numbers. Everything after this semicolon is how we're formatting negative numbers. And then if we had another semicolon, the next part would be how we're formatting zero values. And then finally, how we're formatting text. Now, if I take a look at my data just here, we're just going to do positive and negative values. Now, I want my positive values to show in green, and I want them to show an up symbol. Now, you'll notice further down here, some of these preset custom formats contain the word red. And you can see the word red is enclosed in square brackets. So I'm going to use that format and specify that I want my positive values to be in green. So we're going to open a square bracket and we're going to type in green and close the square bracket. Now I'm going to add a 0 on the end here because remember 0 is a fixed placeholder. I'm then going to open some quotes, space, and we're going to insert a symbol. Now, if you want to insert a little up symbol, you can do that by pressing the keyboard shortcut Alt 30. And that's going to give you that nice little triangle. And then we're going to close our quotes. Now, notice in the preview above what that's going to look like. So it's going to still show the value, minus 19, but we also have an up arrow. And because I've specified green, I would expect the number and the up arrow to be showing in green. Now, before we do that, let's move on to how we want our negative values to be formatted. So we want a semicolon in there. Now, this time I want my values that are under target to be in red. So we're going to open a square bracket and type in red. We're going to put a 0 in there, open a quote mark, do a space, and then this time we want to use the keyboard shortcut Alt 31, and that's going to give us a down arrow. Let's close the quotes. So right now I'm just formatting positive and negative values. Let's click on OK and see if that works. And I can see, yes, that it does. However, there's something about this that I don't really like. This green color is really difficult to read. So what I'm going to do is I'm going to switch this green for a slightly darker green that is easier on the eye. So let's select our range again. I'm going to use the keyboard shortcut, Control-Shift down arrow, Control 1 to reopen up our formatting. And instead of green, I'm going to use color 10. Now, Excel has this color palette where we have colors called color 1, color 2, color 3, color 4, so on and so forth. And if you want to know what all of those colors are, you can simply Google that. But I know that color 10 is a much nicer shade of green. So let's click on OK. And there we go. It's much easier on the eyes and a lot easier to read. So this is looking pretty good, and I can immediately see which actuals were under the target and which actuals were above target. Now, the final thing to point out here is notice here for electric toothbrush again, this was the one where we had a 0 as the variance because the actual and the target were the same. Now, currently, because we didn't specify anything for 0 values in our custom formatting, it's showing with an up arrow, which doesn't really accurately represent this number. So let's make a modification to our custom formatting. Control-Shift down arrow, Control 1. I'm going to go to the end here. We're going to add another semicolon. So now we're into formatting 0 values, the third part. Now, what I basically want for my 0 value is I just want a line or a little block instead of an up or a down arrow. And I want that block to show in purple. So I'm going to open a square bracket, and this time we're going to use color 13. I know that is a really nice shade of purple. Once again, we're going to have a fixed placeholder. We're going to open some quote marks. And this time, the symbol that we want to use, we can access using the keyboard shortcut Alt 22. So we get that block symbol instead. Let's close off our quote marks, click on OK, and you can now see that that 0 is more accurately represented. So very quickly there, we've managed to create a really nice looking custom format using symbols and different colours. So this is a really nice thing to have a play around with and a practice with. But hopefully that gives you a little bit more of an understanding as to how you can incorporate things like colour and symbols into custom formatting to make a really meaningful spreadsheet. In this lesson, we're going to take a look at advanced conditional formatting. Most of us should be familiar by this stage with the regular conditional formatting options. We can find conditional formatting on the Home tab underneath the Conditional Formatting drop-down. And as we know, in here we can do things like highlight cells depending on if they're greater than a certain number, less than, between, equal to, so on and so forth. We can create some top-bottom rules to highlight the top 10 items, the top 10%, so on and so forth. And then we have some pieces of visual conditional formatting that we can apply. So things like data bars, color scales, and icon sets. Now in this lesson, I just want to go through some of the more advanced ways that you can use conditional formatting. And I have some examples just here. And I will say that these are pretty practical examples that you could probably think of scenarios in your day-to-day work where this would be useful. And in the process of doing this, we're also going to get to practice other skills such as creating formulas and also inserting checkboxes. So let's dive into the first example. Now notice here I have a small table, and this is an Excel table. You can see if we go up to the Table Design tab, I've actually called this table Students. And this table shows a list of students, the block that they're located in, the subject that they're taking, and who their teacher is. And maybe I want to be able to select a student from a drop-down list in cell B3 and have it highlight that particular row in the table to really highlight that student to me. We can do all of this using a combination of data validation and conditional formatting with a formula. So the first thing I'm going to do is I'm going to set up the data validation drop-down list. Now all of the student names in column A, they're already unique, so we don't have repeat students in here. These are all unique values. So that means we can just dive in and create the list. So let's go to data. I'm going to go to data tools. We're going to click the drop down and choose data validation. Now on the settings tab just here, we want to tell Excel that we're going to create a list, and then we just need to provide the source for our list. So the source is this list of names just here. Now remember, you are using a table here, so instead of actually selecting them, we can simply hover our mouse over the column heading until we get that black down facing arrow and click to select the cell range. Let's click on OK. Notice we have a drop down arrow, and when we click it, we now have all of those names in the bottom. And the cool thing about having this data in a table is that if you add any new students onto the bottom, this data validation list will automatically update. That wouldn't happen if our data wasn't in a table. Remember, tables make everything dynamic. So now we have our drop down list, and I'm just going to select a student. Let's go for Olivia Smith. Now what I want to happen here is that when I select Olivia Smith, I want the entire row in this table to highlight in a bright colour. Now we do this by utilising conditional formatting. So the first thing we need to do is select all of the data in the table. Notice that I'm not including those column headings. We can then go across to the Home tab, into conditional formatting, but this time we want to create a new rule, because we need a formula in order to be able to do this. So underneath select a rule type, we're going to choose use a formula to determine which cells to format. And then down here, this is where we can type our format. So basically what I want to say here is if the name in column A is equal to what we've selected from the data validation drop-down list, apply formatting to the entire row. So what does that look like in terms of a formula? Well, if we type in equals, all we need to do is select the first cell in the column where we're going to find the student name, and that is cell A7. Now notice when you select the cell, it puts the cell reference into the formula field, but it automatically makes that cell reference absolute by adding in those dollar symbols. Now if I was to keep this as an absolute reference, when I apply my formatting, it's only going to format the cell that contains the name, and we want it to format the entire row. So it means we have to change the way that we're working with these references. And we need to employ mixed referencing. Now with our mixed referencing here, we want to say lock the column because we're always referring to the name in this column and we need to be able to move down, but keep the row unlocked so that the formatting can move across this row. So I'm going to press F4 until I get to this option just here where we're simply locking the column and not the row. So we're going to say if this is equal to what we've selected in cell B3. Now in this case, we can keep this as an absolute reference because we always want to reference whatever is in cell B3. We don't want it to move anywhere. So now we have our little formula in there. We can click on the format button and we can choose the type of formatting that we want to apply. So I want to apply a fill color and I'm going to apply this bright green. In fact, let's do it very slightly lighter. Let's click on OK and OK again and check out what happens. It's selected Olivia Smith. And if I change this to somebody else, let's go for Mia Taylor, you can see that that person is now highlighted in the list. So this is a great way of utilizing data validation and conditional formatting to make a really nice looking table that highlights different rows. Let's take a look at another practical example. Now we have something slightly different here. In column A, we have a list of tasks, and then running through columns B to H, we have the days of the week, and then on the end here, we have a column titled complete. So what I want to do here is I want to use this as some kind of task checklist. So I want to add checkboxes, and every time I complete a task for the day, I can just simply check it off. So that is the first step, inserting the checkboxes. Now in Excel 365, we have a brand new feature for checkboxes, and this makes the process of inserting them a lot easier than they were before. Before we had this new feature, we would have to go to the developer tab, we'd have to insert, we'd have to choose the checkbox form control, and it was quite awkward maneuvering those form controls around. Now, thanks to a recent update, if we go to the Insert tab, notice we have a dedicated checkbox button over here. And all we need to do is simply click it and it puts in these really nice looking checkboxes. And the cool thing about these, again, this is something we couldn't do previously, is that we can change the color of these checkboxes as well. So if I want to make these look a little bit more in keeping with the table that they're in, I'm going to go to Home and you want to change the font color. So I'm going to go to here and let's just change this to a nice green color to change the color of those checkboxes. Now you'll notice with these that if you select one, take a look in the formula bar, it says true. So effectively what we have here is a little true-false toggle. When the checkbox is ticked, the output is true. When it's not ticked, the output is false. So what we want to say now is that if every task for the week has been completed, we want an output of done in column I. Now to do this, we're going to use if and COUNTIF. So let's type in equals COUNTIF first of all. Our range, well, this is going to be our range. Comma, what is our criteria? Well, remember, when these are checked, the output is true. So we're going to say, check in this range to see if the output is true and if it's equal to 7. Because we have 7 days, in order to get a completed status of done, every single one of these checkboxes needs to be ticked, effectively marked as true. So let's hit enter. Notice currently, if I copy this down, we're going to get a whole bunch of falses. But if I tick these checkboxes, and it's worth noting that you can actually use your spacebar to check these as well, as soon as all 7 are ticked, notice the completed status changes to true. Now, I don't want the outputs here to be true and false. I want it to say done if it is true, and I don't want anything in the cell if it's false. So this is where we can wrap this in an if. So let's go up to the formula bar. We're going to type in if. Our logical test is being generated by this formula just here. And then we're going to say if it's true, we want it to output done. If it's false, we don't want anything. Let's close the bracket, hit enter. You can see that first one has done, and I would expect everything else to be empty when we copy this formula down. So I've just gone in and I've checked a few more boxes just so that we have a few dones in column I. Because the final part of this is to apply conditional formatting. Because I want this to do something else. When we have a completed status of done, I actually want the task name to fade out to grey with a strike through so I know that it's complete. So the first thing we need to do here is just select the cells that we want to apply the conditional formatting to. Then we're going to go up to conditional formatting, new rule, use a formula, and this time we're going to say equals if this cell, and again we're going to change this to mixed referencing by pressing F4 twice, if that is equal to done, then we want to apply the conditional formatting to the selected cells. So I'm going to go to the Format tab. We're going to go to the Font tab because I want to make sure that we have a strike through, and I want to change the color of the font to a light grey color so that it really kind of grays out. Let's click on OK and OK again, and we should find that that has been applied. So you can see here it's really obvious which tasks have been done and which haven't. So if I was to go through, and let's take this second bunch of checkboxes, I'm just going to press the spacebar to check all of these. Notice that that conditional formatting applies. We have a complete status of done, and it's grayed out with a strike through. So those are a couple of practical ways that you can utilize conditional formatting with other features in Excel to produce some things that look really effective. It's time now to do exercise 9. And in this exercise, we're going to practice some skills that we've learnt in this section of the course. And this section was all about custom formatting. So you can see here we have a list of students, and all of these students took a test, and that is test 1. And we can see the score that they achieved in this test. Now, all of these students failed test 1 because they got a pass mark of under 50. So they were required to retake the test. And in column D, we can see the score they achieved when they retook the test. So the first thing I'd like you to do in the result column is I'd like you to calculate the difference between the test 1 result and the retake result. And you should get either a positive or a negative value in column E. Once you have a value in column E, I'd like you to apply custom formatting as follows. I'd like you to format the positive values in green or color 10 and show an up arrow. The negative values should be formatted in red and show a down arrow. If you'd like to see my solution to this exercise, then download the exercise 9 solution file from the exercise files folder. That's it for now. I will see you in the next section. A huge congratulations everyone for making it all the way through to the end of this Excel 365 intermediate course. I think you'll agree we've covered so much over the balance of this course, and hopefully you feel by now that you're starting to master some of those key Excel skills. The aim of this course was really to take you from beginner level all the way up to intermediate. And if you've completed all of the lessons and all of the exercises, you should be well on your way to becoming an advanced Excel user. Now, at the end of each course, I always like to just do a quick recap of everything that we've covered. We started out in the first section with an introduction before going through some spreadsheet fundamentals. And then we moved into taking a look at logical functions, so things like if, nested if statements, COUNTIFS, and SUMIFS. We then moved on to everybody's favourite lookup functions, where we explored VLOOKUP, index match, the newer XLOOKUP, and saw some cool things that we can do with those. We took a deep dive into sorting and filtering our data before taking a look at a few different techniques we can use to compare different datasets together. We looked at statistical functions, so things like mean, average, mode, and explored math functions in more detail. We spent some time taking a look at formatting techniques that we can use to really make our data come alive. So with all that said, it is about time for me to say my goodbyes. I hope you've enjoyed running through this course as much as I've enjoyed hosting it for you. My name's Deborah Ashby. I hope to see you at some point once again in the near future. Bye for now.
If you're not a subscriber, click down below to subscribe so you get notified about similar videos we upload. To see the full course that this video came from, click over there. And click over there to see more videos from Simon Says It.